Hello? Please sit as quick as you can, okay? Okay, we are about to get started, so just rest a little bit and we must be ready. Please remember, do not touch anything. So, Robert said on the keyboard, do not touch right now. So, let me just tell you that the following. We work hard in order to solve all the problems that were identified yesterday. So hopefully everything will be fine today. Okay? Remember to check the notification from the documents as soon as you start. I don't know.
with the sanitizer, which was last way down, I don't remember. But they still create the fact that there is no limit on the stock in this computer. I think you will find that clarification in those drafts, but if you want to use a sanitizer, then you have to type in the terminal unit minus S and then a number. Because most of you may already know, but the current configuration is equivalent to if you had typed unit minus S unlimited. That doesn't work out very well with the sanitizer for reasons that I don't understand. So if you want to use the sanitizer, then you have to change it. I will try my best to find someone who can tell you the precise information before the beginning of the process, but I don't know the precise code. Okay, the clarification of those data that we will be able to see at the very beginning of the process contains this information. So we will
So you didn't say the letter. I think the most important.
Hello everyone, good morning. I'm here with Kevin. I'm Duarte. We are here at the EUC. We are covering the European Championship. This is the contest day. This is where everything will take place. We are here at the University of Porto, Faculty of Economics. Hi everyone, good morning.
Hello, and we are already 7 minutes into the contest. There are some problems which have been tried, but so far there are no solves yet.
That is true. It's important to remind everyone that this contest is first based on the number of problems solved. So everyone must try to solve as many problems as they can in the 5-hour time window that the contestants have.
Yes, and should we explain exactly what the UC is?
Sure, of course.
So the UC is the final region championship of the region of Europe. It combines the top teams for regionals. So the Southwestern Regional, the Southeastern Regional, the Central European Regional, and the Northern Western Regional. And this contest decides which teams are going to the World Finals from Europe. And from each regional, already 3 teams qualifies, and we are going to decide the 4 remaining slots.
Yeah, that is true. This is the second time we are having a super regional here in Europe. This is the second time this is happening. In North America, we used to have this contest as well, but this is a second time we are having it here in Porto. So yeah, we are almost 9 minutes into the contest. We have a few submissions. All of them were rejected. We see a team from the Netherlands, one of the strongest teams here today. Problem J, but got wrong answer.
Yes, and we can see here in the right side that there is a queue. This queue represents the submissions of the contestants live, and we can see that the submission for K was wrong answer, so it was incorrect, and
yeah, so they got wrong answer. Basically, in one of the hidden test cases that the judges created, in which their programs are judged on, they produced a wrong answer, so it was not correct. So we now have a submission on problem A. Will it be the first accepted of the contest?
I don't know.
We'll see. Let's see. And now another submission, problem J. Will we have? And we do have a first accepted into the contest. First AC, problem A. École Polytechnique, they one of the strongest teams here as well. The first accepted of the contest, first accepted, problem A.
Yes, and might I remind you, the École Polytechnique team was the champion of the Southwestern region. And this is in fact the first solve of the entire contests. So I think we're going to see more solves shortly.
Yeah, maybe on problem A as well. Now that teams know that problem A is probably not that hard. We'll have other teams following with it. Let's see. But apparently teams are still doing problem J, but a lot of rejected runs in there.
Maybe should we see how the scoreboard is to see? Yes,
yeah, definitely.
Sorry. So far it seems that
yeah,
only École Polytechnique has an accepted.
Yeah, the only try on problem A, I think. So they were the first ones to try problem A, the first ones to get it accepted. Other teams seems to be working on problem J and problem K. Yeah, pretty much. Yeah, an even distribution there. A lot of wrong answers. Probably some corner Ks, something that the teams are not considering.
Yes, maybe problem J or problem K is harder than what it appears. So.
Yeah, definitely.
Shall we check the statistics to see how many submissions do we have in other problems?
Yeah, I mean, I think for now we are only seeing submissions on J and K, and not much is going on. Yeah, J5, K3. Yeah, that is true. the teams are still trying problem J.
Yes.
Problem J, 6 wrong answers as of now. Problem K, 3 wrong answers as well.
Yes, and the fact that it is a wrong answer instead of time limit exceeded maybe indicates that there is in fact some corner case that the participants are not considering in both problems. So
Yeah, that's probably the case. We are now seeing the screen of the team that is in first place. So they got accepted in problem A first solve, as we said, but they seem to be reading the problems, right?
Yes.
They are probably checking the other problems, checking the scoreboard. They are probably seeing a lot of wrong answers on problem J, and they don't want to commit that early, I would say.
So might I remind you also that trying a problem many times is not very good for your penalty, since when two teams have the exact same number of problems. Wait.
Yeah, we just got an accepted on problem J.
Yes.
The first one.
Solve. Yes. First solve.
We can take a look at the scoreboard now. It was not on their first try. They first got a rejected run, but they now seem to have figured out what was wrong and they got accepted.
Yes. And we see a try on problem D and problem B. Interesting.
Okay.
But both wrong answers. And
yeah, since they were able to fix problem J that quickly, I would say it's probably some small corner case that the teams are not considering.
yes,
Bad things happen.
I also think problem J and A are going to be the easiest.
Most likely. Ooh,
Since-
we now have a submission problem. H runtime error. Wow, okay, interesting.
So
Interesting.
people seem very distributed in the beginning of this contest, which is not very usual, I think.
Yeah, not at all. And we have 2 accepteds in 2 different problems. That's not very usual, and a lot of tries early on. Probably the teams may be misjudging the difficulty of the problem. Let's see. Very interesting start here in the EUC contest. We just have 2 accepted so far, 15 minutes in. This is a bit unusual.
Yes, and it's also not very usual to have this many runtime errors or wrong answers. Oh, and we are currently seeing the screen of Maastricht University. They were the team that first solved problem J.
Yeah. Yeah, we see that they got the wrong answer shortly after accepted. Yeah, maybe n equal 1, some boundary case. That may explain why it was rejected in the first try. Yes. But I would say a very slow start here. Usually things are a bit more chaotic at the beginning, but teams are starting slow, but that doesn't mean anything, right?
Yes, I mean it means that even the easiest problems in this European regional are not trivial problems. They require some strategy or problem-solving skills.
Yeah, that's for sure. We have 11 problems today, if I'm not mistaken. It's not a very high number. Probably that justifies why some of even the easier problems are more difficult than usual.
Might I remind you also that last year there were also 11 problems, so far the contest seems similar to last year.
Yeah, that's for sure, but let's see how things go. Teams, I would say, teams are now being a bit more careful since they have seen so many wrong answers early on, and since penalty is a deciding factor, they don't want to accumulate too much penalty here at the beginning.
Yes, we can now see the distribution of submissions in problems, just one accepted in A and J, and the people are trying many different problems, problem B, problem D, H, J, and K.
Yeah, that is true. I would say that teams will be focusing on problem A and problem J in the next few minutes. Let's see what's going on. No submissions in the queue either, so teams must be being a bit more careful now. It's not good to accumulate that penalty that early on.
Yes, it probably means that teams are now reading the entire problem set and checking which problems are easier, which problems are hardest, and prioritizing their strategy. So
Yeah,
let's see.
we should remind everyone that this is a team contest, teams of three, but they only have one computer, so the coding time is very valuable. So there are many different strategies that teams can use. They usually start reading the problems early on. They divide the problem set in three parts, and each of them starts reading some problems. And once they feel comfortable, they start coding. But there are multiple different strategies, right?
Yes, there are in fact multiple different strategies, and we see another submission for problem A. So maybe this time we got another accepted.
Let's see, and
Yes,
it is
another
accepted.
accepted.
Another accepted. Wow, very interesting. The third accepted of the contest, the second accepted on problem A.
Yes, and it was 18 minutes on the contest.
80 minutes, yeah.
A little bit late.
Yeah, I don't recall seeing a contest with only three accepteds in such a stage after almost 20 minutes. I would say it's a bit rare, but quite interesting. Let's see. Let's see. Probably teams will now be trying problem A even harder. Let's see. Oh wow, problem J, University of Zagreb. Another strong team, but they got wrong answer. Wow.
Yes, they are the champions of the Central European region, I think. So
Yeah, that's wrong answer on problem J. Problem J is definitely cutting a lot of people off guard. Interesting. Yeah, now, wow, this is very, very unusual, I would say. But let's see, let's see. We have 5 hours of contest, 20 minutes in, a lot of time for the teams to solve the other problems. Yeah, another submission problem, Jay. Another wrong answer. Wow, okay. Very interesting. Okay, now let's see how things are at the scoreboard. We see the teams in the first three places, the only teams with problem solved.
yes, and in fact,
A lot of wrong answers, a lot of rejected runs. Yeah.
that is a very strange start.
Yeah, I don't even think that in the World Finals we have such a slow start. Usually teams start a bit
Another
more.
wrong answer for problem D.
Yeah, another wrong
So,
answer. Wow, this is a bit unusual, but let's see, let's see. Well, first submission problem F, I think.
Yes, I think it is.
Let's see. Wow. Okay. Let's see if it goes through. We are waiting for the verdict of the judges. Wow, it's accepted. Accepted problem S.
Yes.
F. Yeah, yeah. Wow.
first
First
solve.
solve. First solve problem F. Wow. Very interesting. And now we just got another accepted problem J. Yeah,
Yes.
we just got two solves.
It seems that teams are now committing to some problem, so we should see more accepted shortly.
Yeah, definitely. Wow. Now another team trying problem F. That makes sense. That makes sense. Let's see. Will it be accepted? And it is. It is accepted. Problem F, the second accepted that we have. It seems like that problem F is not that difficult after all.
Yes, maybe teams did not see problem F earlier because it's in the middle of problem set. Usually teams either start at the beginning or at the end, so maybe that's why problem F was solved so late in the contest.
Yeah, that's true. Now we are looking at the screen of the team that just got accepted on problem F. they are reading another problem. Yeah, that makes sense. They are not solving anything else at the moment. That makes sense. A runtime error also. Very interesting. Yeah, we just received here the problem statement. Very interesting.
Yes,
Yep.
indeed. So
Problem F that just got solved. Not a very long description here. Interesting. Yeah, and in the meantime, we will see what the teams are doing. Another try on problem F. Let's see, will it go through? And it is accepted.
yes, I think problem F is now the most solved problem now. So maybe teams start looking at the scoreboard, see that problem F is most solved, and start
Indeed.
focusing on problem F.
Now we are looking at the team in the first place. They still reading another problem. Probably looking at the scoreboard and communicating between themselves, saying problem F is not that difficult. Let's do it. So for now, only one problem solved per team. Another try on problem K. Problem K. Let's see. Will it go through? The judges time limit. Time
so-
limit exceeded.
Maybe problem K isn't as easy as some teams might consider, since it is getting a lot of tries, but no solves yet.
Yeah, definitely. The team in first place is not solving anything yet. They are still thinking about another problem. Yeah, looking at the scoreboard, pretty similar to what we had before. We still have only 7 accepted. Another try, problem J. Let's
Wrong
see.
answer.
Wrong answer. Wow.
So
Very interesting. Now we will take a look at the scoreboard of teams not yet qualified to the World Finals. Let's see if any of them has an accepted. I think so. I think one of the teams already has a problem accepted. Wow, indeed. 4 of the teams not yet qualified to the World Finals have solved a problem.
may I show the scoreboard? Oh, wait a second. So
Yeah, a try on problem J, wrong answer. First try on problem C, wrong answer.
sir.
Wow. We have a lot of different problems being attempted by teams this early on. This is very interesting. I
Yes.
see at least 7 problems already, 7 out of 11 already with some try. That's very interesting.
yes, and the sequence we can see in the statistics. Many
Problem-
problems are being
Problem
tried.
D right now, wrong answer. Wrong answer. Problem A, one of the easiest in the contest it seems. Will it get accepted? The third accepted,
Yes,
it
third
is.
accepted of problem A.
It is.
So that is interesting start from UC. We are 25 minutes in the contest, and it seems only 8 accepted submissions.
Indeed, almost 30 minutes in now.
And no team has solved 2 problems yet. So
I think we will have a second accepted early on. University of Zagreb now trying problem A. Will it go through? Let's see, one of the strongest teams here as well. Will they get accepted? They
Yes,
do get
they
accepted,
did.
problem A. Now they are all tied with 1 problem, but now we
Yes.
see that the penalty is a deciding factor. That's why teams need to solve them as quickly as possible with as little mistakes as they can.
also, might I remind you that this scoreboard is probably going to change a lot from the beginning until the end, and also we won't know what will happen in the final hour, because the final hour the scoreboard will be frozen, and we do not know the results of the submissions.
That is true, Kevin. In the last hour, we will see that teams have submitted. We will not know what happened We'll see. We'll speculate a lot in that final hour, and the final results will be revealed in the closing ceremony later today. University of Oxford trying problem C. That's very interesting. Wrong answer. Yeah, wrong answer. Seems like teams are looking at problems. They think they are easy. They try them, but it fails. Probably some error. Now problem A. Wrong answer. Wow. A very uneven distribution, I would say, here at the beginning. It's a bit unusual, right? Because teams are seeing that problem A is solved, problem F is solved, but they are trying these very different problems.
Yes, maybe because they haven't looked at the scoreboard yet, or maybe they think they have a solution. We do not know yet.
Yeah, it's very important to remind
Another
everyone
accepted
that
on problem
yeah,
J.
problem J got accepted. That is, yeah, usual. I would say we will have many accepteds on problem J and problem A very soon. But it's important to say that teams now have access to the scoreboard, so they can see what others are doing. So definitely that's a strategy that they use. If a problem is having a lot of solves, it probably means that it's not that hard. So teams want to focus on that, so they get accepted and a reduced penalty as well.
Yes, and another try for problem A.
Problem A again, let's see. And
another
accepted. The teams
accepted.
just got accepted. Problem A. That's interesting. Let's see. Let's see how
it
things are
seems-
looking at the moment. Everyone, we just a problem solved. We have the University of Zagreb with an accepted and a try on problem J.
But it seems that Ecole Polytechnique is still leading. Okay.
Let's see how it goes. Yeah, we now have problem A being one of the most solved, and during this transmission we will invite judges to explain their problems, explain the solutions.
Yes, and
Hello everyone, we are back here at the EUC Championship here in Porto. Now I'm here with a guest of mine, the judge for Problem A. Hi, hello.
Hello, hey, my name is Alice, and yeah, I'm a jury here, and my contribution to the set is problem A, which was apparently the first solved problem, which was not exactly the expected event, but I was thinking that it might happen, because it's not a difficult problem, and it's the first in the set, so if many people see it, some of them might solve the easy problem, so
Yeah, definitely.
happy
and-
to deliver the first balloon.
Yeah, and I think it's the most solved problem now. Problem A, teams didn't start with it, but some others started with problem
Yeah,
A.
that's a scoreboard effect, right? If you see that someone solved, like, what are the solved problems right now? A, J, F, I think, right?
Yeah,
If
we
you see-
can take a look at that. Let's
Sure,
see.
let's
Let's
take a
try
look.
to take a look at the problem solved.
Um,
Let's see. Let's see.
Okay, yeah, that's what I saw, right? A, F, G, and if people
Exactly.
see the scoreboard and they sit in the room and they don't know what to solve, that would be your kind of the prime candidates to start working on, right? So I think
Definitely.
whatever the problems which was solved first, it would have been like the most candidate to work on. So it's kind of the scoreboard effect, which is always funny, right? We'll have the online contest starting in 1 hour, and we'll see if the same problems will be solved first or some different problems, because like sometimes the same contest which is done in multiple sites will have like the different easiest problems and so on, just because teams discover stuff in different order.
Yeah, that's very interesting indeed. I would say that problem A started with the first accepted, so teams follow with it, but it depends on what happens in the real contest. Yeah, but we'll surely see more accepteds on problem A very shortly.
Yeah,
I
for sure,
think.
for sure, yeah.
But
So the problem A is a constructive problem. You need to design a specific construction, and yeah, it's maybe not immediate one, but I think it's not too difficult to come up with it if you're thinking about it.
yeah, definitely. Do you want to go over a little bit more about problem A, about what it is about?
Yeah, let me introduce the problem A, and
Sure.
we'll discuss the solution afterwards. So the problem A is titled Condorcet elections because it's inspired by Condorcet paradox. What the problem is about? So suppose you have voters and you have candidates. Suppose you have n candidates, and I would like for each voter to have a permutation of how they rank the candidates from the most preferred to the least preferred. So maybe if I'm saying that, hey, this is voter A which votes for 2, 3, 1, it means like 2 is the most preferred candidate, 3 is the second most preferred, and like 1 is the least preferred candidate. And there are multiple voters like this one. So maybe let me add some more voters. I think this would make a good example. This is an example from the statement, by the way. So now I will say that, let me remove this A. Let me say that candidate A beats candidate B if A is earlier than B in like over 50% of votes, right? So for example, if you look at this example, candidate 1 is more popular than candidate 2, right?
Yeah.
Candidate 1 beats candidate 2. Moreover, because it beats it in this vote and in this vote, but it doesn't beat it in this vote, but it's still more than the half. By same argument, you can observe that candidate 2 beats candidate 3, right? And candidate 3 beats candidate 1. So it's kind of, if you think about it, it's kind of a fun cycle of preferences. This is
Yeah.
actually what is known by Condorcet paradox. It means that in this scenario, you cannot kind of elect the winner in this election, because like suppose my winner is number 1, but hey, more than half of people actually would like to trade to 2, but hey, let's change to 2, but then the same happens with 3. So that's kind of well-known problem, although we don't know if people would know it in advance, but we have it in our statement. But what this problem itself is about, you are given the graph of preferences. Like I know 1 beats 2, 2 beats 3, 3 beats 1, 1 beats 4, 4 beats 3, something like that. So you're given a directed preferences graph, and you need to construct the voters list such that this preference graph is implemented, or say that it's not possible, but the fun part about this is always possible, although we don't say it in statement. You can just always present the list of votes which satisfy that. So perhaps we should discuss how we can solve it, or people would on live stream would want to think about it for a second.
Maybe. I don't know if we should move with solutions because we have the mirror in just a
Yeah.
second. I don't know if we should do that
I
just
think
now.
I think we should do solution, right? But you think?
It's up to you. You are one of the judges. You let me know if we want to go over the solution. We go over the solution.
I think we just will not be getting back to the same problems again. So
That is
if we
true.
started,
That
it
is
might be
true.
convenient to finish it, right? So let me
Yeah,
discuss
sure.
the solution. So the solution is actually pretty easy, but it's a little bit creative to construct. So suppose you have two people, let's say people 1 and 2, and I want to make sure that in the final preference 1 would be 2, and like nothing else would change, right? So like I only, in a way, I kind of select one, I zoom in on one edge of the
Yeah.
graph. I want to satisfy it, and I forget about anything else. Can I do it? The way I do it, I just add 2 votes. One vote which will look like this one, and another vote will look like this one. Well, you note that like the first vote is kind of like 1 blah 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 n.
Yep.
The second one is kind of n blah 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 1, except I swapped the last one, right? If I would just wrote like 2 and 1, those votes would just cancel out each other, right? So like if I compare candidate A and candidate B, like and I wrote it like blah 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 3 to 1, like in one permutation one would beat another, and in the other the second beats another. So like nothing changes. But
True.
if I make this small swap in here, like what you would notice that like 1 beats 2 in both of them. But if, for example, would compare like 1 and 3, you see that 1 beats 3 here, but 3 beats 1 here. So it's kind of, it's, if you think carefully about it, you notice that if I add 2 such votes, 1 will beat 2 in both of them, but everything else will cancel out. So in a way, if I just add all of those votes in, it will be it will satisfy every preference I want, and it takes me about 2 times n choose 2 votes, which is at the most n squared. Which is more than enough to pass.
Yeah, that's definitely a cool solution with a cool observation. Yeah, that explains why we have some solutions in problem A after we have
So yeah, it's
seen the
as I was saying,
construction.
it's
not that difficult.
It's
yeah.
not that difficult to come up, but of course you don't know what to come up for. So you can
Yeah.
consider different things and maybe not all of them.
Yeah, constructive problems are always a bit like that. You either get the gist of it and you kind of find the solution, but sometimes if you don't find it, it can be a bit difficult.
For sure.
They can depend a lot, and during our conversation, we actually see that problem J as
I think
surpassed.
problem C was solved actually. which
Problem
was
C was solved, that is
Yes.
true. We have a solve on problem C that's very interesting. Were the judges expecting such an early solution on problem C?
I actually let me see what the C was. I don't remember it by the letter.
Yeah, there are a lot
C
of
was,
problems.
oh yeah, actually C was one of the sorry, I forgot the letter, but I think C was on the short list of the easy problems.
Okay, that makes sense.
Yeah, it's like it's not everyone's guess what the easy problems is, but at least it was on my short list of easy problems.
Okay,
And I
okay.
think not only mine, so people will solve it as well. So a lot of I think in our contest we'll have a lot of solvable problems. Like I would say there is no probably problems which are like impossible to solve, but of
Okay.
course none of them are equally easy, and we'll see who gets to solve what.
Yeah, let's see. I would say that we have we had a very unique start. I would put it like that, because we have a lot of different problems being tried by different teams. We are reaching a point where almost every problem was tried, which is very interesting. We are 40 minutes into the contest, and we got an acceptance there on problem B as well. I just saw ATH Zurich. Wow, very interesting.
So very curious to see how it will converge from here forwards, right? Because
Yeah.
if different teams solve different problems, of course everyone who like competes for the top position will have to collect all of that stuff together. But like, what is the route to the success? Like, what was the best things to focus on? Maybe you solved like a unique problem early on, and then you suffer with a more common one. That's also not unheard of. So very curious to see what will
That
go
is true.
forward.
I would suspect problem A, F, and J will be solved from here on by quite a lot of teams, and then they will probably focus on problem B, problem C as well. They have some solves, so teams are looking at the scoreboard. They are seeing pretty much the same information that we are seeing at the moment. So they are surely communicating between themselves and saying, "Oh, this is the easiest problem."
Yeah,
we should
for
read it."
sure, for sure. I think it's a very interesting moment to be sitting in the contest hall. You see like a lot of balloons, a lot of action right now. So hopefully it goes well for contestants. My best wishes to all of them, and hope they have fun either way.
I'm pretty sure they will have fun with this very fun contest here today. A lot of different submissions going on, a lot of different problems. This usually first hour, the first 2 hours are a little bit more agitated while things stabilize, and then we see a lot of the top teams with the same set of problems solved, and they start cracking the remaining ones one by one. But we'll see. Problem B starts being more solved now. That's interesting. We see a lot of teams, problem F, problem J. But we still don't have a lot of accepteds. We see that the top 12 teams have one accepted only.
I think it's fine, right? So I would say that there are like many kind of easy or approachable problems, but it doesn't mean the easy means that if you put effort into it, it's like a good chance that you'll solve it without like too long battle. But it still means you have to put effort, right? So you cannot put effort into all the problems together, right? So of course, yeah, different teams will have different problems right now.
Yeah, that's true. We have only 3 contestants, only 1 computer. They have to manage their time quite well, so it's understandable. But we are here fighting for a place, 4 places actually at the World Finals this year. We already know they will be in Azerbaijan, Baku.
Nice.
We'll see what happens. Europe here fighting for.
But to specify, some teams have already qualified. So it's
That
not
is
like,
true.
So it's not like top 4. So it's not like we are battling for the top 4 positions. Probably the people who already qualified will also have a higher likelihood. I'm like the probabilistic problem because it's not probabilistic, but we had a very interesting probabilistic solution which turned out to be false last night before the contest. Yeah, so I would say there is a higher likelihood that those top positions are also filled by the teams who are already qualified, so it's not like we are competing for the top 4 positions. I think more people will advance, not just in top 4 positions.
That is true. We are now taking a look at the scoreboard of teams that already qualified to the World Finals, and we see that one team that already qualified, called Polytechnic, the winners of Zwerg, they already have 3 problems. 3 problems, that's very interesting. Yeah, we see a lot of strong teams here. These teams already qualified, so of course they are really strong. We'll see them in the World Finals this fall. It will be surely an interesting contest there that we'll have in Azerbaijan.
Yeah,
Let's
for
see
sure.
how things go. We will take a quick look at teams that are not yet qualified and see how are they doing. Yeah, very interesting. We actually have a team that hasn't qualified, and it is with 3 problems solved as well now.
Which one?
The one in the second place, global second place. Yeah, very interesting. I think that justifies why this championship was needed, right? Because we had 4 different regionals, and of course there were some disparity between them.
Yeah,
and
for sure.
Such a super regional makes things a bit more even, I would say.
Yeah. I would say that I came from Northern Eurasia region, and we had this system for a long time, and I think it was working well in the sense that like we. Or they now, because I'm not living there, elect the top teams by who did best in like EUC like contest, like the last contest before the finals, and because all the slots distributed are there, you kind of give a lot more opportunities to universities. Like it's not like you have like couple regions and like you need to beat like top 2 or like you're out, right? It's even if you're strong, it's like a very small margin to be always like top 2 and all. But if you, for example, like collect all those slots together, it's a more even competition. I think it was kind of nice one.
Yeah, I agree with that. That definitely makes things a bit more easier, and I also think that it incentivizes teams to keep practicing and working on their competitive programming skills, knowing that they actually have a chance, right? If we have a lot of strong teams and very limited spots, it's of course very difficult to go to the World Finals, the World Finals of the ICPC, the most prestigious university level contest. So teams, of course, want to attend the World Finals.
Sure,
very
sure.
prestigious.
I think it's a very interesting event, both if you're competing for the top results, as we have been trying in all day, but also if you like just happy to be there. I think it's a very interesting place. You get to meet like people from different universities, maybe some professors from other places. You can build a network. You can get to know interesting people, and you can also get maybe connected with someone who will offer you some like professional position later on. I think it's a very interesting place.
Yeah, and I would say it's a very unique environment where we have the top teams, the top competitive programming teams of the world. So that's very
Yeah.
challenging environment, a very stimulating environment as well, because it's not only about the competition. Of course, everyone here is to compete. Everyone in the World Finals is there to compete, but it goes much beyond what the competition really is.
Yeah, for sure, for sure.
We meet a lot of nice friends. We get the opportunity to network, as you were saying. That's very interesting. It's a very interesting environment, a very unique environment.
So last time I was a competitor was in 2020 Moscow, which was 2021 Moscow because COVID, and so what I was implying is that 4 years passed, and still when I, for example, came here today or like a couple days before, because we had like events yesterday already, like I meet a lot of people I already know, right? Because if you meet nice people, they often will be connected to you wherever you go.
Yeah, that's true. That's the beauty of it, I would say. We meet
Yeah.
friends and not only contestants, adversaries. We meet people that we want to connect with, people with similar likings, people that enjoy competitive programming.
Yeah.
Which
So-
is not something that we find everywhere. Probably in universities we have other students as well, but they are not so inclined to competitive programming. So in here it's very interesting to see a lot of people that really love this world.
Yeah, for sure. I think we had much more judges than just me waiting to present their problems, so I think I should give them the spot to shine about their creations, but it was very nice to talk to you.
Thank
and
you,
once
thank
again, best wishes to the teams. Hope they do well, and we'll be looking how it goes from the jury room.
Thank you. We will continue here covering the UC live contest. We'll see how things go.
Okay, so we are here with another judge, Egor. Hello, Egor.
Hello.
So, would you like to talk first a bit about yourself?
Sure, I participated in ICPC until 2007, and then I finished university, participated in different other programming competitions, won some.
Yes, so you are quite experienced in competitive programming.
Yes.
And which problem did you set?
I set problem K, which is not yet solved.
It seems so, but teams are trying, so maybe it will solved. And what do you think that the judges are expecting this scoreboard at this hour? Or
I mean, we probably expected some other problems to be the easiest ones, but generally it's about like we expected.
yes, and should we talk now a bit about problem K?
Sure.
So, could you explain me what is the statement of problem K?
Yeah, sure. We have like amusement park rides. We have n rides. Nth ride starts at each minute that is divisible by AI. So it's AI, 2 AI, 3 AI, and so on. And we have like a company of friends who want to take all the rides, but they obviously can't ride, can do 2 rides in the same minute.
Okay.
And so the question is, what is the earliest time when they can finish?
All the rights.
Yes, all the rides.
So maybe can I ask you, how did you get the idea for this problem? Is there like a story behind the problem?
It was like I just was thinking about this construction, and it kind of came up. It was kind of a top-down problem, so you have usually 2 ways to get a problem. Either you start with a solution and then come up with some idea of what you want to ask. So you already have some algorithm or something like that.
Yes.
And you come up with a statement based on that algorithm. Or it is the other way around. You come up with a problem and then you solve it. Mm-hmm. And that was the case where I just came up with the problem and then I solved it.
Okay, so would you like to explain the solution for this problem?
Yes, sure. So we have this AI. Let's say that we write this at time b1, so on bn.
Yes.
That means that a1 divides b1, an divides bn.
Exactly.
And we want to minimize maximum of bi.
Yes.
So how do we do it? We actually built a graph with source. Then for each unique a, let's say we have k different a's, p1 to pk, and there is q1 to qk occurrences of p corresponding to p in this sequence.
Okay.
So we would have these vertices, and we would have edges with capacity of corresponding q. Mm-hmm. And here we have vertices for each number, and we have an edge with capacity 1 if there is, say, there is an edge with capacity 1 if p2 divides 1.
Okay.
And then we also have edge of capacity 1 from each of these to the thing.
Okay.
So the question is how many vertices we have to add here so that the flow would be n. If we just add vertices one by one, it is too slow. It would be like this, where E is the number of edges.
Okay.
But if we do some tricks, like we only add edges if the number divides like only at vertex if the number divides at least one of this, and also if we add a vertex that divides some of this, right? And we want this won't get our flow bigger, then we won't ever add edges to these vertices anymore. They are already done.
Okay.
And this, it can be proved that there would be no more than n plus k vertices added to the right half until we have a flow of n. So the solution would be like this. And then it can be proved that E is actually n log n in this case. And that's the whole solution.
Oh, that's interesting, but it seems like I'd say not a very easy solution since it involves flow. So I don't expect it to be solved as fast as the other problems.
Yes, the thing is, when the guy who solved our problems before the contest to help us assess them, Kevin, he solved all the problems but this one.
Oh.
But another thing is, I read the solutions that submitted so far. All but one of them is not very good in terms that they just have some greedy solutions that do not work.
Okay.
But the one of them is actually quite close to correct. They do flow, they almost do everything correct, but they, instead of incrementally building this graph, they do a binary search.
Oh.
And with binary search, it's additional logarithmic complexity, and so it won't work.
Okay. So, and what will you think will be the top teams at the end of this contest?
To be honest, I don't know much about these teams to say which one are favorites.
At which time do you think will your problem be solved? Like 2 hours, 3 hours?
I hope someone would solve it before the contest will freeze, but I'm not sure. It depends. It depends on what other problems would be solved, because there is a scoreboard effect. If someone solves the problem, everyone tries to solve the same problem.
Yes.
And for K, so far, because there is no correct solution, people are kinda, we will do it later, maybe.
Okay, so you think because of this scoreboard effect, people will solve it later than what it actually would have been?
I mean, there's a lot of problems with kinda the same complexity. Maybe maybe mine is a little bit harder, but maybe not. And it really depends on if some team decides, okay, whatever, we will try to solve this problem, and if they succeed, there may be a lot of submissions. And if nobody solved it, maybe it won't be solved at all. But I hope all problems will be solved by the end of the contest.
Yes. Do you also think there will be unsolved problems in the end of the contest?
I do hope that all problems will be solved, although I don't think one team would solve all the problems.
Okay. Which problems do you think that maybe solves only by a few teams?
Well, it's problem K. There was a couple more problems that are not very easy, but I don't remember their letters.
Okay. So. Okay, so I think we can end here. So thank you very much for your problems. Thank you very much for the problem set. So. Thank you.
Hello everyone, we are back here at UC. Hello, how are you doing, Azat?
Hey, yeah, it's been a long weekend, but I'm finally here. I've been dreaming about going to Porto for a long time, actually.
How do you find it here?
It's incredibly sunny. Like, I came here from Britain. Obviously, London is not the most sunshiny place of all time.
Oh, not at all, not at all.
It's really annoying. Here it's wonderful. The sky is blue, no clouds. Amazing.
And we actually got pretty lucky because the weather this weekend is amazing, absolutely amazing.
Yeah, it's also like the local architecture, the fact that it's actually pretty cheerful. I don't know, this was a blast.
Yeah, we are in a city with a lot of history, so there's no wonder that you feel that way.
Yeah, and the bridges, whoa.
Yeah, the bridges, the seasides, everything, the food as well, I would say. It's a strong point here of Porto. I'm pretty sure the teams have also enjoyed it quite a lot.
Yeah, and it's also a very enjoyable competition, you know. For some of them, it's not as stressful because they already competed and they
That
already
is
go
true.
into finals. But for most of them, it's actually a pretty big step. They have a chance to go to finals, they have a chance to compete on the highest level, they have all the necessary requirements to be there, you know?
Yeah.
To be in Baku, to see the weather, to see how the finals feel, and I think for most of them it's going to be an amazing chance.
Yeah, without a doubt. I think that most of teams were pretty anxious about this contest. It's normal, teams feel stressed about it, but we see that we already have a team with 6 problems solved. And the team in second place is actually trying problem age, but they got rejected. They didn't got accepted on problem age. But we see that a lot of teams in the top 12 are actually already qualified for the World Finals.
Yeah, and for them it's not obviously as stressful, but they still actually make mistakes. One of our friends over here in analytics sent us an interesting screenshot. So let's look at this. So this is Team ETH Zurich trying to solve problem H, and they had a very particular bug. You can see it's like 2 lines.
Yeah,
And-
definitely.
And they tried to solve it for like 15 minutes at least. Yeah. So like even for them, like they are a very competitive team. They know how to solve these problems, but even they struggle because of some of the pressure, obviously.
Yeah, and they are in the first place. We should add that, and it was such a minor mistake. That definitely happens. I also would like to add that one of the strongest teams that we have here in competition today is a team from Hungary in the 31st place. They probably are the team with the strongest contestants individually, but they are not doing so well at the moment. But we clearly anticipate some more changes in the scoreboard in the near future because they are really strong. And despite not having the best start, I do believe that they are going to solve a lot more problems in the next few minutes.
That's a big problem for even advanced teams. If you like have this feeling, oh, you know, I'm gonna win. If you are very confident in yourself, sometimes it can play against you. Even like
Yeah.
at the last finals, you can see the MIT team struggling a lot with some of the pressure, and I think it can happen with some of these teams because it's already been roughly 2 hours.
Yeah.
You don't see yourself in top 5, top 6 on the scoreboard, and it's actually a lot of pressure. For example, like even like good teams like I don't know, like Neapolis University, I think they're quite decent, and they still struggle a lot. I also expected to see Oxford ranked a lot higher. Like, for example, like is a traditionally good team.
Yeah, we also have a lot of teams from Poland that are not in the top 12, but I suspect that it will change in the future. They are really strong teams, and this is a 5-hour-long competition. The teams don't have to have the best start in the world to win it. So it may be the case that they have a slow start, but they are consistent throughout the whole competition, and in the end they come back and they actually get a medal, get in one of the top places. So a lot will change. We should say, and despite having a lot of problems already solved, for example, ETH Zurich, it doesn't mean that they will get the first place. There's a lot of time, a lot of things can still happen in these hours that we have left.
Yeah, definitely stuff will happen. Definitely we will see a lot of new changes, and I want to remind the viewers that after 4 hours we will not see the actual results.
Yeah.
So for the first 4 hours, the scoreboard you see is the actual scoreboard you'll be at the end, but after 4 hours, all the submissions will be marked with the yellow coloring. The reason behind it is we will not actually know if they are correct or not. So we'll see some approximation of a scoreboard where some problems are colored yellow, and during the closing ceremony, there will be a process of them slowly revealing the results of each of them. So actually, the only time you know the top 5, for example, and a lot of stuff could change, is during the closing ceremony. They'll slowly reveal what is happening, who is winning, and obviously announce the winner.
Yeah, definitely, and a lot of things can happen in that last hour. Sometimes it's a slow hour for some teams, but other times teams solve 2-3 problems in the last hour, and that can completely change the scoreboard. So we will see what happens. We invite everyone to watch the closing ceremony, of course, to know what the final results are. And we are now taking a brief look at the statistics of the problems. We see that problem A, problem J, problem F, problem C also a lot of accepted submissions, accepted runs from the teams. Problem B is starting to being solved by some of them as well, and problem H with only 2 accepted from the teams here. Quite interesting, I should say, that problem H only has 2 accepted. One of them being from the team in first place, of course, but the other one from a team in the 22nd place. This should not be a surprise also because this team is really strong as well. Yeah, I'm pretty sure they will now invest in some of the easier problems, for example problem C, and they can very well climb to the top of the scoreboard.
Yeah, there's quite a high chance of that happening. I think some of the stronger teams tend to not look at the scoreboard as much, ease some of this pressure, and that sometimes leads to them having better results, but also sometimes means they don't solve easy problems as fast. And of course there's a punishment for that, because the scoring system is progressive and you get scored on how much time you took to solve the problem, and you get disadvantages by the amount of negative submissions you made. For some of them, it can be a disadvantage to not solve these questions early. It might lead to them being tied on the amount of problems and having a bigger score, which in turn means that they're lower.
Definitely, but let's see. Sometimes it happens that these teams actually solve more problems than the others in the last hours. We shall see. Everything is up for grabs at the moment. We will see how things progress here at the EUC contest in Porto.
I want to see the team I'm actually cheering for this tournament. This is Technische Universität München.
Okay, let's
short
see.
TUM. I need to screen.
Let's see what they are up to now.
Yes, they didn't have a great start, and they're trying very hard to solve problems which are kind of advanced. You can see the timeline. They didn't have as much luck with easy problems.
Yeah.
Maybe they're nervous. Maybe something's going wrong.
Yeah, maybe they just picked a harder problem than what they were expecting. We see now that they are working on problem C. After 3 wrong attempts on problem H, they completely switch problems. Maybe one of the teammates is debugging on paper, but now they are working on problem C.
Well, it makes sense,
It does make sense, yeah.
You should submit A and C as fast as possible. You should try to have some ideas on other problems. I'm quite surprised that a lot of people have wrong submissions problem K. It would be interesting to see what is the source code, what are they struggling with, what are their ideas, because as we all know right now, it's not the easiest problem in the set. It's actually quite complicated. So maybe just the fact that the statement is kind of short, maybe they assume there's some easy hack to solve this problem. I don't know.
Maybe, yeah, definitely. If the description is not very long, I mean, the problem is also a bit more appealing than the others, and it's also the last problem in the set. So usually teams divide the problem set into 3. So if one starts from the back, it would be the first problem that they see, and it could have been the case that they saw this problem, they thought it was easy, they submitted, and they got wrong answer because of some corner case. That's can happen, definitely. We now are taking a look at the screen of ETH Zurich. They seem to not be working at the computer at the moment. They are probably working between themselves, trying to figure out what the next step is. they are in first place, so they have to decide what to do next. All problems that they have solved have been solved by everyone else, so they now have to solve an unsolved problem, I believe. Yeah.
We'll see. You know, for them probably it's not the most important part of this contest today.
Yeah.
I think they're qualified.
They have already qualified, yeah.
Yeah, so like they're just fighting for respect.
Yeah.
And we're gonna look at more teams, we're gonna discuss more stuff, and we're gonna see a judge in a couple of minutes.
Thank
See you all.
Thank you. See you all.
So, hello, and we are here with Giovanni. He is one of the judges. Can you tell me a little bit about yourself and your experience with competitive programming?
Yeah, sure. I'm now a math professor at the University of Bologna. I used to participate in competitions like IOI, Code Jam. I never participated in ICPC, unfortunately. I very much regret that. But I was a coach for my university, which is Scuola Normale. And in the past couple of years, I've been a judge at SWERC and EUC, and I very much enjoy, coming up with problems and taking the time to think about them, about the solutions, and maybe I would be a bit out of shape to actually participate in these competitions right now.
So, it seems that you are already experienced as a judge, and which problem did you propose?
Yeah, so I proposed and prepared the problem H, which is status, which has been solved recently by a couple of teams. I was expecting it to be a little bit easier than what it turned out to be. But still, it is in the sort of medium difficulty range for this contest, I would
Yes,
say.
and would you like to explain the problem for us here?
Yes, absolutely. So in this problem, so let me maybe write a little bit. You are in a two-dimensional city, and your task is to place statues around this two-dimensional city. So there is already one statue which is given at the origin, 0, 0, and you are given another statue at some other point, AB. Okay. And then your task is to place n minus 2 more statues, say one over here, one over here. In this case, n would be equal to 4. And the way you need to place these statues is by ensuring that the Manhattan distances between first and second, second and third, and third and fourth statue and so on are some given numbers. So you are given 0, 0, AB, and you're given integers d1, d2, d3, and so on. You need to decide whether it is possible to place the middle statues, and if it is possible, you need to come up with an arrangement of such statues.
Okay, so would you like to also explain the solution of this problem?
Yeah, I can go a little bit into it. So the key intuition is that there are two conditions that together are necessary and sufficient for a solution to exist. So it is convenient to give a name to the distance between the first and last statues, which you kind of know. This is going to be A plus B. And once you look at this sort of polygon, of which you know all the side lengths, you definitely need the sum of these side lengths to be an even number. This is easy to check. So d0 plus d1 plus dn minus 1 needs to be an even number. And the other necessary condition is that the triangle inequality holds for each of these side lengths. So each side, di, has to be at most the sum of all the other sides. So d0 plus d1 plus di minus 1 plus di plus 1 plus dn minus 1. So it is, these two conditions are clearly necessary, and that I think the first important idea is that these are actually the two correct condition because they are also sufficient to build a solution. So I guess one needs to have a little bit of intuition to sort of, guess that these conditions are also sufficient. And once you have done that, there comes the second part of the problem, which is to actually construct an arrangement of the status. And you can do that inductively. So you can start from the end. You can try to place the n-1th stadio, and you can place it on the perimeter of a square. Like these are all the points at distance d3 or dn-1. Okay, and doing a little bit of work, you can always come up with a position that allows you to maintain these two conditions, like make sure that they still hold on the remaining n-1 stadios. So you want to inductively sort of preserve these two properties so that you can continue the induction, essentially.
Okay, so I can definitely see why some teams are getting wrong answers. So this next step of constructing and viewing that these conditions are necessary and sufficient is not an easy step. And there might be some corner cases that you as a judge definitely considered. And I would like to also ask you if there is like a story behind this problem. Like, how did you came up with this problem?
Oh, I see. Well, the story is very pragmatic. We were missing some easy problems, and I was trying to come up with an easy problem. And I actually I had an initial version of this problem where I think you didn't have to check like whether it was possible to arrange the stadios, but rather like in how many ways you could arrange the stadios in some slightly different scenario. And I talked a little bit with Federico, who's the chief judge. My original version had actually a dynamic programming solution, so it was actually a problem of a slightly different flavor. And then we discussed and we decided to go with this version, which is actually in some ways substantially different because there is no dynamic programming going on now. It's really, I guess, a greedy problem. And also it is not, apparently it's not an easy problem either. So like the way we started off was, we changed the problem quite a bit from there.
Interesting. So as a judge, I think you also are seeing the scoreboard and how the teams are performing. And yes. Do you think, how do you think the scoreboard will be at the end? Do you think that your problem will be much more solved than what it is now, or do you think that there will be major differences in the end?
So about my problem in particular, I was initially expecting it to be solved more. Looking at one or two submissions, it looked like many teams are struggling with actually getting the two right conditions. Apparently, it might be easy to, to miss, I don't know, using D0 or checking the triangle inequality at all side length. So my updated prediction is that it will be solved by more teams, but maybe not by the majority of teams. So maybe half of the teams might be able to solve it. And overall, for the overall scoreboard, I think judges are a little bit divided on whether all problems will be solved or not. And my opinion is that not all problems will be solved. Maybe do you have the scoreboard here?
Yes, I think we can show the scoreboard now.
Because I don't want to
so
say something which is already wrong. That would be very embarrassing.
yes, you can see the
Okay, okay.
scoreboard now.
So I personally don't think problem G will be solved. I think it's substantially hard, but there is no consensus among the judges on this, and not all the judges actually think that problem G is the hardest. So I think there is some discussion between E and G on which one is the hardest.
But do you think that all the problems will be eventually solved?
No, I don't think so.
You don't think so?
I would bet that problem G will not be solved.
Well, that's a different opinion than Egor. So Egor
I
thinks
see.
that every problem will be
I see.
solved, and I definitely think that if people want to be on the top, that they will have to solve your problem.
Yes, I think
since
so. I absolutely think so.
it's the next step after the 5 problems A, B, C, F, and J.
Yes, yes, definitely.
So I think we can end the interview here. Thank you very much for your
Thank you,
problem.
Ken.
Thank you for your time.
Sure.
Thank you.
Bye bye.
Hello everyone, I'm here with Lucian, who is the judge here and also the author of Problem I.
That is correct.
So how do you find Porto so far?
It's, I think, one of the most amazing cities I've been, like, in my whole life. I didn't know about Porto so much, like I didn't see pictures of Porto. I would have imagined it in a whole different way. So I thought it would be like level because it's very close to the sea and to the ocean, but it actually has so much depth in terms of altitude and like all these buildings and just like wandering around the city and the streets is just amazing. Like not even the tourist attractions, just walking around Porto is an amazing experience.
What is the thing that stood out the most to you?
Could you please repeat?
What is the thing that stood out the most to you?
I think just the architectural style of everything and the fact that there are no two streets that are the same steepness, so like the same angle. You know,
Oh, yeah, right.
It's there's like this whole new third dimension which you don't find in many cities.
You're always going uphill or downhill. It's always a struggle.
Exactly.
Yeah. So this is obviously a big competition for us. This is essentially a semi-finals for a lot of teams. They're obviously somewhat nervous. Do you have a favorite team that you cheer for?
I mean, I try to be impartial, you know, because I'm a judge,
of course.
and of course, but like teams in Romania, it would be great if they do well. I mean, it would be great if there's going to be a team going from Romania to the World Finals, and that all depends on their performance at this contest.
Right. Do you want to see a team from Romania on screen? Do you want to see what they're looking at currently?
Sure.
Do you have a name of the university?
Let's look at the team from Iași. I'd be curious because I think they're now on the top 10 teams or something like that. I think they were on bronze. It's like UAIC.
Yes. Let's look at them. So they apparently are working on problem K right at the moment.
Problem K.
Yes.
I mean,
Do you think that's the right choice?
I wish them the best. Let's see which problems have they solved already. They've solved B, A, C, F, and J. Is that correct?
Yeah. They haven't solved D. They have yet to solve D.
I don't think anybody has solved D, so I'm not sure if D would be the right problem. I think
there is a chance.
I think D is a problem that is either rather easy or like incredibly hard. So it's like it's not in the middle, and it's very easy to start with an incorrect approach, and like if you stick to that incorrect approach, you're probably not going to have a very good time solving it.
Yeah, they probably can solve K at the moment. It seems solvable at least. We heard the solution to it, obviously, but we're not here about the problem K. We're here about the problem I, which is the author of.
Yes, so I am the author of Problem I, which unfortunately hasn't had any submissions yet. I certainly hope it will have some submissions and some accepted submissions. I think it's on the maybe on the harder side, but not the hardest of the hard batch. Maybe one of the easiest of the hardest batch. That is how I would describe it. But ICPC is full of surprises, and usually the way judges let's say judge the difficulty of problems is a lot of times different from what the contestants judge as the difficulty of the problem. So yes, problem I, pinball is my problem. Should I describe it or?
Yeah, you should probably describe it.
Yeah, so it's like a game with a ball. I can maybe make a drawing, which like the drawing is sort of on a grid. I'll use the example for it. And we have some nice drawings. Which actually, fun fact about these drawings, with this problem I realized how bad ChatGPT is at generating tile sets. So like for games, you know, I wanted to generate a tile set to make the drawings for this game and tried ChatGPT and had no success. So
I really like the fact that the drawings here are pixelated. It's like a pixel art mixed with a problem set. It's really nice.
Yes, and I mean it kind of reflects my artistic skills, you know. I couldn't have made something that was more complicated, so I went with like the simplicity of pixel art, I guess. Is that enough?
Yeah.
6x4. Okay, so we have a 6x4 grid in this example, and we have some walls which are sort of like obstacles. A pretty standard way of encoding 2D grid problems, I guess. And we have some oblique walls. And there's also a ball that's initially here. So the ball is really small. It's encoded with an S in the problem. And the idea here is that we would play the game as follows. We would nudge the ball in a direction and the ball would move freely, like without friction. For example, if we nudge it in this direction, in the left direction, the ball would just trace this sort of cyclic motion and reflect off of walls. So it will reflect off of block walls and it will reflect off of oblique walls. But of course, with the oblique walls, it reflects at a certain angle. So right now, if we nudge it in this direction, it would just like cycle like this. So that's pretty boring. But what we can do in this game is at any point in time, we can like just destroy, just make, for example, this wall disappear.
Okay.
And if this wall disappears, then the ball would change its trajectory. Because like if the ball goes like this and we destroy this wall, so we essentially convert it into a free cell, the ball would continue moving in this direction, right? And it will come to this wall. And then continue on, and then start going on a different trajectory. So, for example, in this case, it will start cycling through this sort of pattern. But again, you can see that if we destroy this wall, the ball would eventually escape the grid. And this is our goal. So our goal is to make the ball escape the grid, and the key thing that we have to take into account is we want to destroy as few walls as possible. So that is essentially the task. The task looks sort of daunting up until you figure out some examples and you analyze a little bit of the structure. So the way one would approach solving it is figuring out first that there are these sort of patterns, like this one, this would be like a region, or this is how we would call it. And this is like one of the starting regions, because you can nudge the ball in the left direction and it will start traversing this region.
Yep.
And this may be another region, for example, which goes like this. Let's make sure that this oblique wall also shows. This would be another region. This maybe would be another region. So this is like region number 0, this would be region number 1, this would be region number 2.
We have multiple colors if it would be easier.
Oh, that's great. That's amazing. So yes, let's use colors and maybe not destroy the blackboard in the process. I'll use a yellow one.
Let's try the yellow one, yeah. Might be easier to see. Okay, it's visible.
It should be visible. So this is one region, this is another region, and this is another region. And the key thing to notice here is if you destroy an oblique wall, you would basically make the ball go from the blue region to the yellow region.
Yeah.
This is not technically 100% correct, because like if you destroy the wall here, the ball would basically cycle through some parts of the blue region and some parts of the yellow region. But if you look at it very carefully, you can realize that in fact there is always some way, some time where you can destroy this so that the ball would traverse into every cell. So like you can make it traverse into any part of the yellow region just by controlling the time where you destroy this.
So can you undestroy a wall?
No, you cannot undestroy.
How can you then get here?
How can you get here in this?
No, in this portion.
In this portion, you can get in this portion just by destroying the wall once the ball moves like this,
right.
and you destroy it before it hits this wall. So it will go in this direction and it will cycle like this. But if you destroy it after the ball hits this oblique wall, then it will go in this direction.
It's a really
so you
cool
can
idea.
already see that just by destroying this wall, you can let the ball be in any of this part.
Yeah.
So once you see that, you'll realize that you can basically just build a graph which has these regions, and the walls are edges between these regions, and the minimum number of oblique walls to destroy is actually the distance between the starting region and any region that ends up with the ball escaping. And now this is like one part of the problem. The other part of the problem is, of course, obtaining a solution, like the reconstruction, the actual simulation. And to do that, one very nice trick, there are multiple ways, some are easier, some are harder, but one very elegant way is to actually start from the end. So we start from the goal, and we see that, for example, if the ball starts moving towards here, like away from the exit, and it reaches this oblique wall, we can actually make it go in this yellow region. The important thing, or like the very elegant thing about going in reverse, is that you're not destroying walls, you're actually creating walls.
Yeah.
So like once it hits this wall, you can do one of the two things. If it's like a wall that you would want to be destroyed, you can just assume that it was destroyed and you like restore it in reverse order, so it starts moving in this sort of zone, and the wall is here, so it's like completely this zone, right? And if not, you just don't destroy it and you continue simulating it. So how the solution would go is the ball would start from here, you'd see this wall, you'd want the ball to be here, so like you restore this wall and continue simulating, and then you hit this wall, which again, you would want this wall to be destroyed, to be in this region, so you restore it in reverse time order, and now you're in this region and you just simulate it until the ball is back in its starting position, and I mean the rest is just implementation.
Yeah, that's really beautiful actually. I like the idea of going from the backwards and just like appearing walls in the order.
Yes, I guess it has a couple of ideas that need to be stitched together in order to solve it, and I guess that's what makes it hard.
I guess the initial idea of the fact you can actually go into any point of the wall path is actually not very obvious to me, at least. And yeah, you can clearly see how the participant might be, a bit overwhelmed by the picture and the quality. Like it's actually a big problem. The solution is really elegant and really nice, but you can obviously see like why there wasn't any attempts to solve this problem so far. Okay, that's great. Thank you for coming to us. Do you actually expect people to solve this? Do you have an expectation of how many people are going to solve this problem at the end?
I think there would be, so my expectation would be around 5 teams, hopefully. So hopefully five teams will have this problem solved in the 5 hours of the contest. I mean, it all depends right now. It all depends on who is going to be, or at least which is going to be the first hard problem to have a solve. So that will certainly happen in the next hour, and that might decide how many submissions all of the hard problems are going to get because of the scoreboard effect.
Yeah, of course.
I guess a lot of people have discussed about it, and it's like a very real thing in this contest.
Yeah, I think people will right now focus on K more, just because people have solutions to that. People will try to solve it, and we
Yeah.
obviously see a bunch of incorrect solutions already.
Yes, and I can now see a first to solve on problem E, so I guess that's going to be a target for someone.
Which is the
Or-
team that solved
it's,
it?
It's a team on
Sorry, yeah.
34th place.
Okay, yeah, let's see.
There is
Let's see what
literally
they're doing.
one submission and
Just a
it's
second,
correct
problem
for problem
E.
E. I think it was recent as well.
Yes, just a second. I need to quickly glance my. I have an interface to see. Okay, let's look at the screen. Yeah, so this is Scuola Normale Superiore. I have no
Yes.
idea how to pronounce this correctly.
And they're not even in top 10, and it makes it just more amazing.
Yeah, but you
to
see
have
that
solved.
it's like not a. It's pretty strong team. They have IOI medalists. They have Court Forces, Masters, and Grandmasters. So
Yes, I guess now they just have to conquer the rest of the easier problems.
yeah, I'm sure they're comfortable like solving C. This seems like a huge goal. They might be a contender to go into places.
Yes, I think anybody who will solve at least one of the hard problems is going to be a contender for the top places, definitely.
As the last question of the day, we asked it to multiple judges before. I'm going to ask you, what do you think will be the cutoff for medals? How many tasks will you need to solve to be in the medals on this competition?
So basically to be on top 12.
Yeah.
I would expect 8 or 9 problems. I'm thinking of maybe 8. Maybe 8. But probably for top 10 places it will be 9. That's my expectation. But like the 12th place. Probably.
Thank you for answering. I'm going to see you again in some time. But we're going on a small break, and I'm going to see you in 20 minutes.
Great.
Bye.
Hello everyone, we are back. I'm here with the chief judge of this competition. Hello, good afternoon. So, what are you thinking about the scoreboard so far?
Right, it's not going exactly as planned. I mean, it's going okay, but not as planned. Maybe the main thing we're not expecting were these many solutions on problem A. For us, problem A was maybe, I don't know, the fourth or the fifth easiest problem.
Okay.
But not the easiest. I guess there was some kind of scoreboard effect. We're also surprised a bit by the fact that problem E was already solved by someone. For us, problem E was one of the hardest on the other end.
And by a team that it's not in the top positions.
Indeed.
And not yet qualified for the World
And
Final.
to be fair, it's exactly from my university.
Oh.
This was my university. But I guess sometimes it goes like that. And they are not pre-qualified to the World Finals.
They are not.
I think that they're strong, but the contest doesn't seem to go their way today. Because, I mean, yeah, they solved one problem that they are the only one having solved, but they wasted an insane amount of time solving it.
Yeah.
So it's unclear if this will be convenient. I'm here talking about Scuola Normale Superiore and problem E. Apart from that, yeah, more or less, okay, I was expecting personally, so judges disagree about the difficulty of problem D. So, how the process usually works is that I receive all these proposals from judges and I try to solve them. And usually, given enough time, I can solve them. In fact, problem D is the only one in this contest that I could not solve by myself. I asked for a hint. But then after a hint was given to me, I thought, oh, but this problem is not that hard. I was just not going in the right direction.
Okay.
So this is one thing. Another thing is that we had a tester. He is a very strong guy, and he destroyed problem D. Like in 15 minutes, he had solved it.
Okay.
And so this clearly changed our perspective on the problem. But still, there is one judge. I think Lucian was speaking here before. He thinks that problem D is the hardest of the contest. I thought that at this point it had to be solved by multiple teams. It seems like he's right up to now. But
Yep.
okay.
No right solution so far, as I can tell.
I'm very surprised by the fact that D has no solution and E has a solution. For me,
Yeah.
E, like, it's much. I mean, the point is that problem D, once you get the right idea, so it's very easy to get the wrong idea, as you can see from the scoreboard. But once you get the right idea, it's almost immediate to code it. It's like 10 lines, 20. On the other hand, problem E, first of all, you have to have the right idea, and then you have to code 150 lines. So it's a bit of a different thing. Anyway, and then to say something more, so my problem in this contest were the easiest and maybe the hardest. So my problem was, I don't know I guess F, mascot naming.
Okay.
It's a somewhat simple string problem.
Yeah, every team has solved it so far.
I guess so. That's expected, that we wanted that, and we are happy that it happened. And the second easiest problem is problem J, and in fact, all teams solved it. This is in fact, in some sense, a test, like, a proof that the teams here are quite strong. Because these two problems, yes, they are meant to be easy for these teams, but in another regional, they would absolutely not be the easiest problem.
Okay.
Like, they are not K-quotes. It's not that you read them and you say, oh, this is obvious at all.
Yep.
So in fact, I would say that teams here are quite strong. Like the weakest team is already quite strong, which is a very cool. It's very cool to have this kind of teams participating. I think that this is not the case more or less in any other contest. Even at the finals, I think that it's not true that the weakest team is so strong. So now let's move back maybe to the top of the ranking. So we have ETH Zurich. They performed very well at the very beginning, and now they're completely stuck. They finished what we consider easy and medium problems, and now they have medium hard and hard problems, and they are not solving more or less anything. There is multiple stuff that could be solved, like K could be solved at this point.
Yeah, K has a solve, E has a solve, so
right, but E seems like, I mean, maybe I'm overestimating it, but E, I was not expecting to have a solve at this point, but K, absolutely it can be solved.
But maybe they as teams, they are looking at the scoreboard and they are seeing A, E is a solve, K as a solve, so probably they are going for those ones, and maybe that's not the...
That's why they are missing D, because D is very solvable. You need to think about it, and if you have the right idea, which I didn't have, but I am sure that many contestants here could have the right idea, you solved it immediately. I think that D will play a big role for the top positions at this point.
Yeah, let's see. They still have quite some time left.
No, they have quite some time.
The scoreboard effect, I think, is influencing them.
Right. I would expect, so my guess is that at the end, so my hope, and my guess too, is that all problems are solved by someone, but but the winner has 9 problems.
9
what I claimed yesterday night. I'm not sure if this will happen. We'll see.
Of course.
I would be very surprised if, well, no one gets 7. I would be very, very surprised because, I mean,
Yeah,
these problems, at this point, maybe teams start to convince themselves that they are impossible, but these problems are absolutely not impossible. I guess that for me, the really hard problems are E, G, and I. G is my problem. Could be the hardest, I'm not sure. Because also E and I, they are difficult for different reasons. I is hard to implement. And E is hard and hard to implement is a bit of everything. But then there is D and K.
Yeah, so D and K are not so hard in your opinion.
Like in my mind, top 4, for example, might have 8 problems. So everything but E, G, and I. And then top 1 or 2, they will have one more, and that's will be the 9. But for me, it's impossible to say which one will be solved because different teams may have different opinions about the difficulty of those things.
Let's see. And so, what do you think will be the medal cutoff for this contest?
Medal means top 12?
Yeah.
That's a good question. At this point, it might be that 6 is enough. 7 might be necessary. It's unclear.
Yeah.
It's really clear that 6 will be necessary. Yeah, because there is still 2 hours or something. Yeah. And I would say maybe 6 or 7, depending how it goes. Because I mean, there is also problem. What's H? H is status. Let me check here.
Yeah, problem H is being solved by some teams now.
Yeah, problem H is a problem that has this strange property that it has more or less 2 solutions. So solving it on paper is not hard. But then implementing it really depends in which direction you go. There is one solution that is incredibly clean, 5 lines,
wow.
but you have to. So it's a constructive problem, and in some sense it's a constructive problem that you could solve also without really doing anything constructive. But it's very hard to implement. Because you'd have to implement something like the intersection of spheres in Manhattan distance, and it gets very annoying very quickly. But then there's another solution in which you make one more assumption, so you constrain, so you have to choose where to put some status, and you are given 2 points, initial point and final point. More or less this is the problem, and then you have some constraint. If you decide, because you prefer, that this status will all be on just 2 lines, one passing through the initial point and one passing through the end point, then this will simplify everything immensely. But it's not clear at all why this should work. So you would have to think about it, notice that it works, and then you can implement it. Yeah. Otherwise, it's a very strange assumption to make.
Indeed, it doesn't seem obvious at all why that would work. But yeah, that seems to simplify the solution quite a lot, as you only have 2 lines.
In fact, I think that teams that were able to solve it quickly, if I have to make a bet, I haven't checked, they are implementing the easy thing, because the hard thing is hard to implement.
Probably, yeah. We had
much harder than getting the idea to solve it. I can easily see people. My audio is a bit broken. Okay. I can easily see people getting stuck. Like they solve it, they say, "Oh, this is easy," and then they start coding and they make a mess.
Yeah, for example, ATH, that was the first solve they have only accepted in their 5th try.
Right.
So yeah, they probably had some bugs. I looked at the code briefly, and it was not that very long, but yeah.
Right.
Those corner cases, those small details. But it's very interesting that, for example, the team that is in first place at the moment is not qualified for the World Finals yet.
Impressive, absolutely. We can also discuss that, like, what are the teams that I would expect? So there are the teams that are qualifying for sure.
Yeah.
ETH is a big favorite here. It's unclear if they will win. So at this point, it's
not clear.
It seems like they are completely stuck. They are not doing anything since, I don't know, 1 hour and a half, maybe more than 1 hour and a half. Completely stuck. Like they did 6 problems in the first hour and a half, and in the following 1 hour and a half they did nothing.
That is true.
While other teams have solved some of the remaining problems. So yeah.
Zagreb is also a really strong team, as we know.
Sorry?
Zagreb, the team in third place.
Like, I mean, there are the expected strong teams, and then there is University of Utrecht that, at this point, I think that it's very likely that if they stop the contest here, they are qualifying for the World Finals.
Yeah, probably with that penalty. With that penalty.
Exactly, because to beat them, you absolutely need to do 7 problems, and at this point, it's unclear if 7 problems would be needed to get into top 4 among the non-qualified. Apart from that, so there is University of Wroclaw that many years has gone to the World Finals. This year is still not qualified. I would not be surprised. Currently, they are barely in Are they? 1, 2? They are fourth. So,
Yeah.
So 4 people qualify for the World Finals.
They are.
They could not.
Yeah.
And then we have some universities that are unexpected for me, but maybe they're strong and I just don't know them. For example, Neapolis University Paphos. I don't know it.
Yeah, I was not expecting it either.
But they're there. Most likely they deserve it, and congrats to them. There is maybe one thing that I can add about problem E. So problem E in the contest itself is behaving more or less as we were expecting, because there is only one solution. Okay. And the guys in some sense struggled in the sense that they didn't do anything else for 1 hour and a half. But somewhat interestingly, in the mirror there are 2 Romanian teams. So there is a mirror public, and 2 Romanian teams have solved it in 6 minutes.
Wow.
Which is a clear indication that the problem was known before. And most likely it appears somewhere in Romania, but it doesn't seem like. So I mean, this can happen, and we didn't know about it. But it seems like the Romanian team here didn't know about it. We the judges tried to search a bit, we couldn't find anything. Who knows? Opa, someone is writing me. Let me just double check that.
Yeah, of course. Nowadays, it's impossible to guarantee that the problem or a new idea wasn't new or anything like that. But I would also add that, for example, the Hungarian team that we have here, they are in 21st place. They are quite strong. Probably even the strongest team based on Gold Forces rating, I would say.
Which one? University of Oxford?
21st, yeah.
21st?
Yeah, the Hungarian team. Here.
Oh, they're supposed to be very, very strong?
Yeah, they have an LGM in the team. Yeah, so it's a really strong team. You know, they are not in a bad spot at the moment, but of course they are not in
I could easily see them perform very well. So there is the point that some of these problems, maybe on purpose, they are meant to be. It's somewhat easy to stumble and get stuck. For example, problem H is really the definition of this kind of problems. Problem H is one kind of problem that you read, and if you are maybe a bit experienced as a contestant, you say, oh, this is easy. Then you start coding it and you get completely lost. This is my experience for sure. And it's not the only one. The same applies to J. Maybe J is perceived as much easier in this competition because it's easier, but still similar issues. Let me add 2 things. So we had a super strong tester, and I want to say it also because he wrote it to me now, that I think that currently he's outperforming not only this team but also the mirror. Like he's he did very, very well. And when he performed in that way, we were wondering, but is this contest so easy, or is just the best day of his life? This was kind of the doubt we have. And another thing that maybe it's to support the fact that the audio is again a bit strange. Yeah. To support the fact that the easiest problem is not that easy, we tried, and we think that ChatGPT solves 0 of these problems.
0 problems. Yes. And also, I would say that the start of the contest was a bit slow compared to other competitions.
The easiest problem is not easy. And they started solving a problem that we didn't even consider to be among the easy ones.
Yeah, in the beginning it was quite interesting because we had a lot of submissions on a ton of different problems, and then they started to converge to problem A, problem J. But the teams took a bit of time to figure out what to do next.
But I think that problem F was incredible that problem F was not solved in the first 20 minutes or something like that.
Yeah.
Because problem F is, for this kind of teams, it is easy. In fact, everyone solved it at this point, but I was surprised.
Yeah, we see that the first solved 20 minutes, exactly. Yeah.
Right. Let me think if I have anything else to add.
So yeah, those kinds of things happen. The scoreboard effect surely plays a role.
Right.
I think that maybe teams started with problems that they thought they were easier, but they were not. For example, problem H, I think that we had
Can I update this scoreboard somehow?
Yeah, we can just split it. Yeah, we just got it. Yeah.
I want to see if someone solved K or D, because I think it's likely that someone is. Well, K was solved once.
Yeah, K was solved.
D is still unsolved.
Nope. D is still not solved.
I think that D should be the next one to be solved. I would be very surprised if no one solves it before the freeze. I would expect it to happen, but we will see if it happens or not.
Let's see, maybe, for example, University of Zagreb has been working on some problem for quite some time.
We can see them?
Yeah, I think we can maybe just see what they are doing. University of Zagreb. I will put it in the transmission in just a second, and we'll get to see what they are doing, because they are surely working on something.
But the same applies to ETH. ETH is not submitting anything since
ATH as
2
well.
hours.
ATH as well. So they are
maybe they're just stuck. It could be that you have this initial moment And then maybe you're already qualified for the finals. I don't know.
Let's see where they are in here. Yeah, University of Zagreb. Let's try to see what they're up to. So it should appear on screen. So yeah, they are definitely working on a problem.
Okay. Yeah, it's very reasonable.
Yeah.
It could be that they can solve it. So problem K, I don't know if someone already discussed it, but it's once you read it, first thing you think is, oh, this is easy. This is a stupid greedy. Then you notice that the stupid greedy doesn't work at all. Second thought, oh, this is a flaw. And then you start to think about it, and you notice that if you implement the flow as you know it, this will get time limit exceeded for sure. And then you have to understand what to do about it.
Yeah, definitely. So they are working on there, and they seem that they have been doing so for a bit of time. I see some testing there, I think, on the right side of the screen. So maybe they will finalize the problem and submit it. We can also take a quick look at ETH Zurich.
What are they doing? Yes.
Yeah, let's see if they are following
very nice,
following the same thing. Yeah, they are coding.
What? I couldn't see.
I couldn't see what they are doing. Let's try again here. ETH Zurich. Let's see. Let's see if we get the feed in the screen. It should come up any moment now. Yeah, that is good. Is that H? I think it's
How can you tell?
on the top.
Like which is the tab there? Oh, it's G.
Yeah, the last one. Yeah,
they're
it's
working on G.
Yeah,
I
it's
would be
G.
so happy if they. So G, that is my problem. It's solvable. It's not like there is no impossible problem here, but I would be very happy if someone solved it before the freeze, because they say something to everyone else.
Let's see. Let's see.
Oh,
if
someone is trying it, by the way. University of Zagreb. Can I check their submission?
Oh yeah, we can. We
I don't know
can.
if you can open
We
submission.
can actually. Well, we can.
Zagreb?
We can take a quick look at Zagreb here. It will appear on screen as we have seen, but it seems like they have since moved to another problem.
They
Yeah,
moved to- they
yeah,
moved to
K.
K, yeah.
Yeah, they are doing K. We can open and see their submissions as well, and see what they are up to in that sense. Let's see. But they switch problems, so that means that they have. Yeah, that they
Right.
have.
I can maybe not the solution, but I can
Gone
at least
to
explain
another
the
problem. Yeah, we can now go a bit to problem G and detail a bit of its description first, probably. Yeah.
So, can I write on the blackboard here?
Yeah, for sure.
Okay. So, problem G is about taking a long walk in a park.
Okay.
So, you are given an n by n matrix or pattern of altitudes. So imagine that n is equal to 3, and I'm giving you this pattern. 3, 1, 0, 5, 1, 3, 2, 2, 2. Random numbers. So you have to imagine that this represents the altitude of each cell. So the world is a 2D plane, and in fact in the statement this was a national park in Portugal, and these are the altitudes. So and this repeats periodically. So 3, 1, 0, 5, 1, 3, 2, 2, 2, and here 3, 1, 0, 5, 1, 3, 2, 2, 2, and so on and so forth in all directions.
Yep.
Okay? Now imagine you want to walk in this park, and how long does it take for you to move from one cell to another? If you have one cell that says X, and one cell adjacent to it that says Y, in order to go from X to Y, you spend 1 second plus the difference of altitude seconds. So imagine that if you are at the same altitude, you just go straight, otherwise you might have to climb, down climb, do something. Okay, so the problem, this is the setting of the problem. And the question is, you start from a given cell, I mean you start from here. How many cells can you reach in R0? seconds.
Okay.
Okay, and one starts to read this problem, and again you say, okay, but this is just dice trap or something. You start executing it, or the numbers are also pretty slow, everything is small, n is up to 20, and you say, oh, but this is just dice, I execute it. How hard can it be? Well, the point is that r is equal to 10 to the 20.
Okay.
So you can have the most efficient, I'm not sure I'm in the screen, but yeah.
Yeah, perfect. We can see it.
Yep. You can be as efficient as you want, but most likely this will not fit in. And then you have to start to understand, like the point is that, okay, everything is periodic, and in some sense you would expect the periodicity of the pattern to have something to do, and the point is that it's not obvious to understand what it has to do with the shortest path.
Yeah.
So I will just, maybe I'm not saying the whole solution, but I'm saying a few things. One nice thing is that at the very end, once you have solved the whole problem, this boils down to a convex hull. You have to compute a convex hull and the area of the convex hull of something, and this will be the solution to the problem, which I find very interesting, because from the very beginning it's not clear at all that this is that the convex hull will ever appear from this problem. This is one thing, and then maybe I say just one thing about how to solve the problem. So, idea of the solution. Imagine that you have a path. So you have a path, which is a sequence of cells of some kind. Okay, this is the beginning, and this is the end. Okay, the cost of this path? We learned how to compute it, taking two contiguous cells and computing 1 plus x minus y. Sorry. Okay, then what you do is that you find in this path, you find two cells that are equivalent mod n. So if n is equal to 3, you find two cells that are equivalent mod n. For example, let's say that this cell might be, I would have to compute a few things, might be equivalent to this one mod n.
Okay.
So mod n. Then what happens is that, okay, you have this subpath that has a certain cost, and if you remove it and you compress everything else, the cost will remain the same because of the periodicity thing. So you have decomposed your initial path into two things. One simple path that begins and ends in the same mod, and everything else, and then you keep repeating this operation.
Okay.
And by repeating this operation, I'm being very sketchy here. You reduce a generic path to one that is made of many short paths that begin and end in the same cell mod n. And this is the main idea. Then you have still a lot of work to do, but it's more on paper, because I would say that once you understand what to do, coding is not particularly hard. It's about understanding how to solve the problem. So it's more of a paper problem than an implementation one.
Very cool problem, I would say.
Right.
It's not clear how the convex hull will appear from it.
Oh,
but,
the idea is that I said to you that any path is a sum of simple paths. And what's the idea? The idea is that there are finitely many and very few simple paths that are interesting. Something polynomial in n, it's not important what. And then you can forget about the fact that you were looking for shortest path, and now you only work with simple paths. And what's a simple path? A simple path is a way to go from a certain cell into another one that is translated by a multiple of n. So an, bn. So a simple path allows you to move in a certain direction, and it has a certain cost, like a certain time, d, associated to the path. So a special path lets you move by a vector divisible by n, and it has a cost. And the idea is that now you forget about the problem, and you want to know, if I can use only this kind of jumps, and the sum of the distances can be at most 10 to the 20, in how many places can I go?
Okay.
Now the problem is a bit more algebraic.
Definitely. Yeah, it's definitely a cool...
Oh, and someone solved problem D. I'm very happy about it.
Yeah, in the meantime, someone solved problem D.
Congratulations to them. This is exactly what I hoped, and I'm very happy that it happened. Now I would be super happy if someone solved problem G, and I'm surprised that no one is trying problem I.
Yeah, nobody's definitely trying problem
Like
I.
this,
At
like
least
nobody
no
has ever
submissions
tried it.
yet, but probably
I
they
think
are.
that it's scary, and also maybe people understand that implementing it would be a mess, which is true. On the other hand, problem G and problem D, once you understand what to do, they are not hard to implement. They are actually quite easy.
Let's see, but we have an hour and a half, a little bit less than that. How many problems do you think that the top teams will solve? Still 9?
I still think that 9 is possible, yeah, it's not impossible, in particular because top teams are not doing anything since a long time.
That is true.
Which makes me dream that, I mean, first of all, there is University of Zagreb that has 2 tries on 2 different problems, which, I mean, how surprised, is it impossible in the next 10 minutes they get both? No, it's not impossible. If they tried, it was because they were believing it a bit. Will it happen? Who knows?
Let's
that's the point
see.
of contest.
Let's see. 1 hour and a half. Our teams still have a lot of things to do.
Yeah. I mean, any team that still does not have 6 problems, they surely have at least 1 problem that they can approach.
Yeah,
After the first 6, then the problems get harder, and the fact that also problem B has so many solutions, that's really a proof of the strength of the teams. I want to emphasize this. Like, I'm really happy about the average team here. It was selected very well by the regionals because only very strong teams reach this stage, which is very nice to see.
Yeah,
I would like to leave just because I have to do stuff.
No worries. Thank you so much for joining
wait,
the
then I
streams.
will wait for.
Let's see. Do you think it will be accepted?
I
Let's
hope
see.
so, I don't
Let's
know.
see. Let's see. Problem J.
I would be very happy.
It's a very strong team, and they do. Wow! Congratulations to them.
One of the judges claimed that this problem would have not been solved.
The perfect way to end
I'm very happy
this
about
conversation.
So now teams know that it is solvable, and
Definitely.
in the freezing time they knew it. The fact that I has 0 solutions, that's incredible.
Yeah.
Like, everything else has been solved. In my opinion, I was clearly not the hardest problem, but that's it. Thank you very much. It was a
Thank you
pleasure.
so much for joining us. Hello everyone, now we are back. I'm here with Professor Fernando Silva, the contest director of EUC. Hello.
Yeah, thank you very much for inviting me.
No worries, thank you so much for being here. How is it like to host a competition like this, the second ever European Championship final here in Porto?
As you might guess, it's quite a bit of work, but this is something I've been doing for the past 20 years or more, a little bit more. And I enjoy it because it's not just for me, but for the community that we support, our students, and trying to motivate them to engage in the ICPC challenges. And so I started in '99 going to the first regional with 3 teams, and by then I was a coach, but then I organized the regional twice, and I kept being
and
involved.
that progressed. Yes, that's amazing to see that progression. And now we are here hosting the second ever European Championship, a competition that's between the best teams in Europe. We remind our viewers that they were qualified from the regionals, and in here they are fighting for the 4 places in the World Finals later this year in Baku.
Yes, I'm quite happy the way it is going, because I see that the teams are performing quite well with good distribution of problem solved. And so it shows that the European the Europe Championship is quite competitive, and it's not a surprise because most of the teams are already very good teams in each of the 4 regions that we have. But it's interesting because now they can see how they perform against each other.
Yeah.
It's a good sign.
I think that it's very interesting that now we have a super regional like this one. In North America, they already have a similar one to this for quite some years. Do you think that precisely for that reason it plays an important role in qualifying teams for the World Finals?
Yes, and I think the way we are doing it right now is we have 3 teams qualified directly from the regionals, and then we have 4 places which are not specific tied to a region, but to the best 4 teams that have not yet qualified, and so this increases the relevance of the competition. And in fact, I can say already that for next year it's going to change slightly.
Okay.
We will have 2 teams qualified directly, and we will have 8 slots being decided at championship.
I see.
So this means that there will be a second opportunity for very good teams also to compete, because sometimes you are a good team, but you might not perform well, and on the second chance you might do better. So it's interesting.
Yeah, definitely. So some exclusive news here that for next year this qualifier will send 8 teams to the World Finals instead of the 4 that we will select today. That's very interesting. Yeah, and do you think that it helps to solve maybe some disparity that exists between regions, because there's some imbalance, right? Or there can be.
Yeah, that could be. But from what we saw in Prague, it was a little bit of a surprise to me. I expected slightly different results, but the 2 strongest regions in terms of the number of teams that they qualified were Swerk, which was not probably expected for many, but it shows how much the level of Swerk has increased. And then Nwerk and Cirque.
Yeah, sir.
Yes,
yeah, definitely.
For this year, I don't know yet how it is coming up, but I think this is we should also have always have a representation of the region.
Yeah, definitely.
To avoid having all the 16 teams from the same region. I don't think that will happen, but I think it's good to have a good distribution of the countries also being represented, although this is a competition of universities, not countries.
Yeah, of course, but this is a competition, of course, but it's much more than a competition. I think that it's a great opportunity for the students, a great way for them to connect with themselves.
The relevance also for the championship is to have another level. So you see, we have competitions at universities, then we have competitions in the regionals, and then this is a level already quite similar to the World Finals, because many of these teams are very good teams to perform in the World Finals. And this is an experience that we provide to more teams than if only the 4 teams would go directly from the regionals to the World Finals.
Yeah, it's also another.
So the outreach is higher.
Yeah, another opportunity for them to practice as well, to be in this environment. But in here we are qualifying for the World Finals. We now know it will be in Azerbaijan, Baku, later this year in the fall. Very exciting. It's a competition for college students, the most prestigious one, ICPC, right?
Yeah. And I'm hoping that previous contestants that have done quite well from our university, they keep being involved, like yourself, in coaching the younger students. So
well, definitely
we do well in the coming years.
Yeah, definitely in one way or another.
We have to renovate, so it's not an opportunity for me to be a coach. It's an opportunity for people like you.
Yeah, thank you. Well, thank you so much. But I think that a lot of that happens quite organically already, because people, I think, like this environment quite a lot, and they want to be involved in whatever they can.
Happening in many of the institutions because I can see some of the coaches that I recognized them from being in the World Finals
Yeah.
a few years back. Not many, but so it means it touches very strongly those that qualify to the World Finals because you have to do so much practice, so much training, that you don't forget it so easily. So you keep wanting being involved.
And speaking a little bit on that, it's a lot of practice, that's for sure. But it's a skill that the students learn that goes way beyond the competition, right?
Yeah, I value very much the skill that this promotes because it's a skill in the algorithms, and the algorithms are. I might be a bit exaggerating here, but I think it's the basis for most of the development and innovation that we do, being AI or other areas. And so I usually say someone that comes from these competitions, ICPC being a world finalist or even a good team in the regionals, these are people that not do just be very careful with the way they program. So they look at the special cases. So after they accomplish a task, we are more or less sure that they have much less errors hidden than the normal programmer, and they do it much faster. So for a company, I think they value this kind of competences and this kind of skills. Yes.
Definitely, the technical skills are invaluable this time around, I would say. But also the teamwork is also quite important because these students are working in teams of 3, so they have to interact with themselves, discuss the problems together, and I think that's really important.
It is, and so being able to use well the computer is something that these teams have developed, and if the team is also balanced in terms of the capacity of each member, these are the teams that do best in the competition usually. Yes.
Yeah, that's for sure.
From what I saw for so many years of experience.
That's for sure. We now see that we have 2 teams in the top with 7 problems solved.
I think they will reach 9 probably.
Let's see this last hour. The scoreboard will be frozen in about 8 minutes, so we will see what will happen in this final hour. But for sure, we'll have some surprises, I think.
From before, unless there is a surprise, we will get to 9, at least. Yes.
Let's hope so. We see that pretty much every problem except problem I has been solved. So other teams are looking at the scoreboard and they are seeing that the problems are solvable. So the top teams now have something to work on. Let's see. Let's hope so. And this year we have medals for the top 12, right?
Yes, for the top 12 we have 2 gold, 4 silver and 6 bronze. We had a coach meeting and people prefer that we do similar to the World Finals, say 4 gold, 4 silver and 4 bronze. So for next year it's going to change.
Okay, so another exclusive new here. Next year 4-4-4, because the teams here, as we have stated, are really strong. They come from the sub-regionals contests that there are, and so being in the top 12 is no easy task already. So that's great news for the teams for sure.
So I've been defending even for the World Finals that we should give about 25% of the teams a medal. And here we are just about it. Because getting a medal is something more meaningful for a team that does well than if you just say I was 14th or 15th.
Of course.
Okay, yes.
Of course, but in here at least the distribution is more or less 25%. In the World Finals it's the same distribution but with a lot more teams. So getting a medal in the World Finals is really tough. But that's why teams practice all year round. I would like just to ask some more questions related to the contest. How is it like to host a competition like this in the beautiful city of Porto, in the University of Porto? How is it like?
Well, so as I said before, we hosted 5 regionals already, and the World Finals in 2019 on a different place, but it was really it went quite well, and this is for me probably my last organization, but I have been lucky because I had always very talented people helping with systems, judges, don't judge, and the volunteers also very important, and it's all this community that makes it possible. Yeah, and of course the sponsors.
Of course, without them we
provide
wouldn't.
funding for us to host such an event.
Without them we wouldn't be here.
Yes,
That's for
and
sure.
in particular, not only the sponsors that are here, but also the University of Porto that provided us also with sponsorship and allowed us to host this. The School of Economics here, the Faculty of Economics, with this building and these facilities made it possible as well as the Faculty of Sciences that they contributed because all the audio and video that we have are people from the School of Sciences. So it's a community effort, and I'm lucky that so many people are willing to collaborate and make it possible.
Well, we thank you for hosting this beautiful competition here, for being the contest director. I'm sure that without all the effort, this wouldn't have been possible. So thank you so much. I'm sure everyone agrees with what I say. Thank you. Anything else that you would like to say? Would like to add to our contest viewers?
What I would like that this concludes well, and that people also be able to enjoy the city because we are lucky that we have nice weather. And,
really nice weather.
And the city is worthwhile visiting, so I hope everyone takes this opportunity to visit. Yeah.
And takes a bit of Porto back home with them, right?
Yeah.
Well, thank you so much for joining us.
Thank you.
friend Josh Gutter and our friend sponsor Pavel Piaski for hours. So.
At the current time, the scoreboard is frozen. You cannot see what result the team gets, and if they submit something, it's going to be displayed as yellow. So for each team, you have two opportunities. First one is they successfully submit the task and they get AC. And the second opportunity is this doesn't happen and they get wrong answer and they're going to be very sad. At the final, after this whole ends, we'll have a ceremony and we'll one by one reveal the results. So this process will probably show us the winner. Do you want to discuss the state of the scoreboard at the moment?
Yeah, I find it interesting that it looks like we have all problems except one to be solved now by at least one team. So all teams have a lot to do. So I expect problem I to be not attempted by any team in this position, because each team has at least 3 problems solved by other teams, which probably should be preferred.
Yeah. Also, I is kind of a complicated problem. I'm surprised so many people solved E actually. I would expect it to be less solvable. Like a lot of judges before said to us that E and G were considered to be the hardest problems for them at least.
Maybe. I don't know. I think I know how to solve both, but maybe with G it's some more problematic because it's hard to verify without writing actual solution, and they didn't. But ideas I have sounds reasonable to me.
Okay.
But maybe there are some more details.
If I'm correct, you've both been here in 2019 Finals Porto, actually.
Yes.
So, what did change? You know, how do you like the city now?
I actually didn't get a chance to see the city this time because yeah, we're doing some very small, of course, last-minute preparations yesterday. Right. So yeah, but from what I was able to see, everything is as beautiful as 5 years ago.
That's nice to hear. So, as far as I remember, you made problem B. Do you want to quickly explain what this problem is about and how to solve it?
Sure, happy to do that. So yeah, anyway, problem B was here, I guess. So you had a grid. And in each cell of the grid, you have to put either a tree or a building, or I guess I will just put ones and zeros. Or maybe I won't even write zeros. So something like this. And after you do this, what you are interested about is how many rectangles are there of ones, rectangles of ones. So for example, this is one rectangle, this is another rectangle, and actually in this example there are only 2. Right, so we count rectangles of 1. And what we want to actually do, we want to solve the reverse problem. This problem is also interesting, by the way, how to count them efficiently. And it turns out you can do it in O of n squared log n time, using some divide and conquer, which actually you can find in a code forces comment 7 years ago, as usual. But our problem is the reverse problem. So we are given the number k, and want to find any grid which has exactly k rectangles. And the number k is at most 4 times 10 to the power of 12 in the EUC. But actually in the online mirror, this problem is more difficult. So there, in the online mirror, we have this constraint, 4.194 to the power of 12. And this is very close to maximum. So if you put, the grid has to be at most 2025 times 2025.
Nice.
And if you make the full grid of ones gives you 4.199 times 10 to the power of 12. So this second harder version is kind of you need to be able to get almost to the full grid and still get any numbers that we require. So there are multiple approaches to this problem, and in fact, I was checking the accepted submissions during the contest, both in the EUC and in the mirror, and they're all different. So it's not kind of, there's infinite amount of approaches basically, and it's not very likely even that two teams have exactly the same approach. But roughly speaking, in the EUC version, what you tend to do is you tend to have several independent components, right? So you tend to first, you build a component of ones, which gives you close to k, maybe not exactly k, but some number close to k. And then you just skip one row, let's say, and in the rest of the grid, you try to make the remaining number. And maybe do multiple such steps, which gradually converge to the given number of k. And one way to do it is to just go like, put one's first row, put one's second row, and so on, until you reach k. So maybe after putting the next one, you would already exceed k, then you don't do it. Instead, you say it's finished, then you skip one row, and then you start again. And then actually it turns out after, like, first block will be something like at most 1977 rows, then the second block will be at most 3 rows, and there will be 6 more blocks of 2 rows, and that's it. So kind of you will converge very quickly, because actually what happens here, kind of asymptotically speaking, is that every time we add a new one, we get a quadratic number of new rectangles, because this corner is fixed and this corner can be arbitrary. So, and the total number is a fourth power of the size. So essentially, what we go after taking one of those, we go from k to square root of k. Yeah, that's why it converges so quickly. We go like square root of k, then fourth root of k, and so on. So, it very quickly converges to 0.
Do the teams actually have this idea, or did you think they just tried and saw that they had not time limit?
So for teams, I actually didn't see exactly this solution. I saw some similar ones. So I think one solution that I saw did the same for the first step, but then the remaining number after you get this is basically 2025 squared, and for that they had a completely different solution that just tries to get this number using the remaining rows.
Okay,
that was
that's cool.
One approach I saw.
Yeah, so some of the judges told us they used ChatGPT to draw the pictures. So as you can see, this solution has also a very beautiful picture with trees on it. Did you draw it yourself?
So it's kind of mixed. So this picture was drawn in Metapost, but I used ChatGPT to generate some small snippets of Metapost. So actually not ChatGPT, I used Gemini to generate some short snippets of Metapost. Because the language is, okay, it was developed by Donald Knuth, so it is, how to say, has its own specifics.
Yeah.
And I use it once a year, so it's quite hard to remember, and then using a language model is a quick way to essentially process Stack Overflow comments into code.
Okay, that's cool. I think it's time to see the scoreboard a bit, see what teams have the chance of going to finals. So if you want to see the scoreboard, on the scoreboard we marked with the green color teams who either already qualified or have the potential to, like, if the scoreboard stays the same as currently, they have the potential to go to finals. Let's quickly select a different scoreboard, which is only the teams who have not qualified to World Finals. Here they are.
Yeah, I was going to say that it seems likely that you will need 7 problems to qualify. Right now, 3 teams with 6 problems qualify, but there are already team from Bucharest and team from Scuola Normale Superiores in Italy, I think, that have solved not the usual 6 problems, but one of the more difficult problems. So they're quite likely to get 7 problems at the end of the contest, I think.
I think it's even possible that you would need 7 with good time.
Yeah, it looks like it. It's like, if you look at the statistics for problems, actually it seems like D, E, G, and K, you probably should solve one of them and have some good time. We'll see. They have an hour. They probably can solve at least one of them. Let's look at some teams. For example, the currently first team, University of Olrecht. I know how to pronounce this. So they appear to be working on problem number K. to be reasonable.
So in problem K, I'm not sure if you already discussed it on the stream.
Yeah.
I think there is a not easy, but solutions that people come up with. This involves binary search and match inside, which gets time limit, and then you need to get rid of the binary search. So I think this provides the team kind of a direction to dig into. So they know in general how to solve the problem. It's just a bit too slow, the solution, and they need to optimize it. So I think it's easy to work towards the solution. Whereas I think in the other problem mentioned, like in D, if you don't know how to do it, it's not, you can just get stuck, I guess. And yeah.
I guess a lot of people try problem K, and I think like the initial idea with the binary search seems kind of reasonable. I think a lot of people got bamboozled by the fact it doesn't get AC for the first try.
I would say among these problems, if you know how to solve it, D should be simplest one. If you have a solution.
Yeah.
I'm not sure is it true about to come up with solution. Maybe it's not that easy, but probably if you have a solution, just implementing it should be easiest.
I think also some people like overlook problem I as well. It's actually the solution is kind of beautiful and it's very natural compared to some other problems.
Maybe
it comes naturally. I'm not sure why. People
I failed. So have you discussed this problem already? So when I was thinking on it, I failed to understand if it's true that whenever it tries to pass through the same deflector twice. Because if it's possible that we can go it from left to right, then turn somehow tricky around and then try to go up to down, I really don't understand how not to count this twice. But it's possible that it's never needed for some reason, which I didn't get.
Did you get the idea of the problem?
No, I have no idea how to solve
so
it.
So essentially, the main idea of this problem is you have these areas where the ball will not escape. And the main idea of the problem is the fact that you can actually get from any area. So if the areas are connected by the wall, you can specify a time for this wall to be alive in, so that you can transfer from any area to any subsequent area. So by then you receive a graph, and you go from the end, and you decide which walls do you want to add.
Okay.
Yeah. It's not like, I think the idea is kind of natural to me, but yeah.
Maybe, I don't know.
Also in the online mirror, where there are maybe 100 more teams solving this, or more even, there are still also no accepted submissions for I, and it's the only problem which is not accepted yet.
Yeah.
So
And
it does seem that people are scared, at least by the problem statement.
We see that there is one more submission from University of Utrecht team. By the way, can you show the whole scoreboard, please?
Yeah, let's show the scoreboard. Hello. Just a second.
Okay. So they at least tried to do problem K, and if they did, they have. If it's accepted, it seems to be good. They then have good chances to win. But
I guess on 7 problems, probably still ETH Zurich has the best penalty time. So if they get 7th problem, they will overtake Utrecht, I would guess.
Who?
ETH Zurich. I think they
Okay.
have like more than
Maybe.
300 minutes less on 6.
Yeah. I don't think people care too much about like winning this competition. I think it's also important, but for them, at least, it's the actual goal is to be on top 4. I think that's probably what they're aiming for.
well, top 4 among not team who didn't pass to finals yet. Yeah, sure, but still winning is a nice achievement also.
Yeah, of course. You always want to at least try to win. But it's looking like they still debugging some issues.
Let's
But
check
it's also
what.
true for the team from Utrecht, but for ETH and other teams who already qualified,
Yeah.
maybe winning the competition, or I actually heard from the coach of ETH team that their goal was also to get as many first souls as possible on the problems. So you have to set some different goals if you are not qualifying for the World Final from this round.
And also,
Let's look at the Bucharest team.
like KT University, which has solved problem D and not solved problem H, also seems like one who have good chances because they probably would figure out H soon, because a lot of team has already did this, and they probably already doing some other problems in parallel. So, and they would have quite good penalty on 8 probably. So maybe they also have quite a good position.
Let's look at one of the teams
which have not been qualified yet, if things are going according to plan, which is University of Bucharest.
And sorry, I don't see them in scoreboards.
They just submitted D. So they already have K and they
Oh,
submitted
okay,
D.
I see.
For some reason, something is not working here. Let's try that. It's alright. So yeah, we also might want to look at the code forces mirror. If you look at that, indeed nobody solved problem I. Problems B, D, and G are the complicated one, closely followed by K. Makes a lot of sense.
But in the mirror, problem B is harder than in the EUC.
Oh, it's a different problem?
Yeah, I was saying that basically it has harder constraints. Like for the mirror, you have to solve for higher values of K, and significantly harder.
Okay, yeah, that makes a lot of sense.
I think we expected that in the mirror, maybe if actually some of the strongest teams in the world are competing, like the teams that got third place in the recent Universal Cup finals from Japan is competing, and therefore we felt that we maybe want to make the problems a bit harder so that they are more, they don't get what's the word, AK in 4 hours.
Yeah. There's also seemed to be a maybe successful submission for problem G from University of Oxford. We can probably look at them as well. Oxford. There might be a chance that our screens are not visible.
Also,
anymore.
Zagreb have now submissions on 2 problems, and that's even before the freeze. That's interesting.
Yeah, it would be possible that they actually at least solved one of them, and quite plausible they solved.
And now they submitted the third one.
Okay.
So they're trying to get 3, which is interesting option. If they would get 3, which is possible, that's probably would be a big claim for the first place. But we'll see.
We can now look at the optimistic version of scoreboard, which is what if all teams actually submit correctly. And here's it. So, University of Zagreb goes way up. Same for Bucharest and Oxford. Interesting enough, Charles University also comes up a lot. And if the not yet qualified teams submit all the current problems, top 4 would be closed by the Charles University. Yeah.
Okay.
I think it's reasonable to expect, 7 problems would probably be necessary to.
Sounds reasonable.
Any chance? Okay, that's nice. So, do you have any final words for the teams watching this competition?
Yeah, Road. I think actually I guess maybe say some general words. I think it's a very, very nice new competition, the European Championship, and I find it really cool that teams can get together before the World Finals, and more teams can come here. Therefore, like 50 teams, and only 16 of them will go to the World Finals. And also, it is held close to home, so people don't have to travel for 2 days to get here. So I think it is a really fun event, and I'm excited to see all the teams competing here. And thanks.
We'll probably see both of you next year as well. So we're gonna have a quick break and return to you with more judges, more problems, and more stagings.
Thanks.
Bye.
everyone, we're back in the live stream, and here I have Boba and Pedro Paredes. Would you like to introduce yourselves?
Yeah, I'm Boba Manova. I'm director of European contest still, and I'm here as a founder, one of founders of Europe Championship. Last year we had it in Prague. This year we have it in Porto.
I remember last year I participated in EUC. It was very nice, very nice experience. And for how many years have you been the director of Europe?
I don't remember exactly, but I think something about 10 years. I started ICPC as a coach of team of students. We get into finals in the United States, and after I was growing up a little bit, I don't mean by my body, but by mind, and we brought ICPC finals into Europe, into Prague. Eindhoven is the first one, and Prague was the second European Championship outside of United States. It was 2004. And from that time I worked for this many years, but I'm still teaching at the Czech Technical University in Prague.
Yes, and would you also like to say a bit more about yourself, Pedro?
Yeah, sure. Yeah, I'm Pedro. I used to compete in the SWORC. I believe my last year was like almost 10 years ago at this point. And now I'm one of the judges. I was the author of Problem E. I'm still involved with ICPC. I'm the coach of the Princeton team from in the US, and also problem setter here.
Yes, so both of you are very experienced already in the ICPC scene, and have you? I assume that you have been accompanying the results lately, right? Do any of you have anything to say about the scoreboard? It is currently frozen.
I didn't compete. No.
You didn't look
but
at the
I was a coach, and still I'm teaching programming algorithmization for contests as a help. I have students, former students now. They are professors and they are teaching this.
And I assume that this is not the first time you are in Porto, since the World Finals were also organized in Porto. So how do you feel about revisiting the city?
Porto for me is one of the very nice and very good town in the world. If I will emigrate from Czech Republic, I will go to Portugal, to Porto. But I was here first time, I think 25 years ago, because I had few projects with University Porto, and we cooperate in some software for education online before the COVID came, a long time before. So
you
nice
like the city very much, right?
Yeah.
And you obviously...
Yeah, I guess I forgot to mention, but I went to college here, so I used to compete for University of Porto when I was a contestant for ICPC. So I did my undergraduate and master's here. So I've been to Porto many times.
We forgot the finals in Porto. It was amazing.
Yes. Since you are the judge for Problem E, would you like to explain a little bit to us about Problem E?
Yeah, sure. So the problem is phrased in terms of soccer, because obviously we're in Portugal, so it has to be about soccer. But in this problem, there are two agents. One is the supporters club of a team, and the other one is the police. The goal and the problem, there's a graph that represents the network of the roads of Portugal. And the goal is, this is kind of like a game where the one of the agents, so the supporters club, starts from a certain node, and they want to reach a different node. So they start from node 1 and they want to get to node n, in the minimum number of steps possible. The graph is connected, it's undirected, it's unweighted, so they just want to go from node 1 to node n. But the gist is that the other agent, the adversary, the police, they can, at some point during their travel, they can block one road, and they pick one road, they'll block it, and they can't traverse that road. And once they block it, the road cannot be traversed ever again, and they can't pick another road, so they can only do this once. And the goal of the police is to maximize the time that the supporters club takes to go from node 1 to node n, and the supporters club want to minimize the time that takes them to go from node 1 to node n. So it's kind of a game where one of the agents wants to get to the destination as fast as possible, and the other one wants to delay them as much as possible by blocking one of the roads, by blocking one of the edges of the graph.
So it seems like an interesting mix of graph theory and game theory.
I guess so. Yeah, it's the problem was thought of like as a little game between two agents. The solution doesn't really need a lot of game theory, but the idea of the problem was thought about like what an interaction between two agents in a graph.
So could you also explain the solution
Sure.
to us in the board?
I can use the board a little bit. So let me actually erase this first. So the key idea to solve this problem is to first notice a couple things. So let's say that we have the supporters club are currently in some node V, and the police hasn't blocked anything. So let's say that V has these edges coming out of it, and so right now the supporters, I can't really draw, but let's say this is a bus where the supporters clubs are traveling on, and they're trying to get to the destination. So once they're in a node like this, the police has two options here. They can pick some road and block it, or they can let the supporters club pick some edge to use to keep going in their trip. So I'll use the following notation. So let's say I'll call f of v to the shortest path to get from V to the destination N, but before the police has blocked any path. So this means that f of 1 is the solution to the problem. So if we define f of v as this, so in this point, like we want to compute f of v, like for this situation that I just described, if the supporters club are currently on node v, f of v would be the time required to get from v to the solution, to the destination. So if the police doesn't block anything, then let's say that they pick some node u to get to. So in that case, f of v would be equal to 1 plus f of u, which is 1 plus taking one of the edges plus the whatever time required to go from u to the solution. So if the police doesn't block anything, the supporters club might as well pick whichever node minimizes this. So in that case, what we actually end up picking is the minimum f of u over all u's that are connected to v. So this is what that we do if the police doesn't block anything. If the police decides to block something, so I'm going to use the following notation. I'm going to write g of v to denote the following quantity. It's the shortest path from v to the destination, where so actually I'll do the following. I'll first define gve. So let's say we have some edge e. So gve is the shortest path from v to the destination that does not use edge e. So we block this edge over here. So this would be gv. So this is basically saying if the police blocks this edge, how long does it take me to go from v to the destination? And then I'll say that gv is like the maximum over all the edges adjacent to v. So using this notation, now if the police doesn't block any edges, then this would be the best decision for the supporters club. If they decide to block some edges, then we have to basically pick between either they block some edge or they don't block some edge. So this would be the maximum between this g of v and this. So to recap, the idea is that if the police block something, the best edge for them to block is the edge that maximizes the shortest distance between V and the destination. If they don't pick any edge to block, then the supporters club will pick the minimum over the adjacent vertices to V. And now so this kind of becomes sort of almost like a dynamic programming type of problem now. But the key thing is how to compute both G of V and F of V efficiently. And I'll just say a couple words about how to do that. I won't spend too much time to not bother anyone. But once you compute G of V, you can actually compute F of V using an algorithm that looks a lot like Dijkstra's algorithm. And the idea is that this formula over here kind of looks like a shortest path distance, so you can use Dijkstra's algorithm basically to compute F of V. To compute G of V, it's a little bit more complicated. And the idea is that you kind of have you have to look at the BFS tree of starting at the destination, and then you have to compute all the possible paths that could go from every vertex V to that destination using the BFS tree. It becomes a little more complicated. You kind of have to use a couple of different things. There's
couple different solutions. Some teams have used the LCA to kind of compute this efficiently. Another solution that we've come up with uses you kind of have to keep track of these sets and then efficiently merge them using a small to large merging. So there's a couple of ideas that go into that, but I guess I won't like go into too much detail. But the main key idea is like coming up with this formulation and then computing GV and F of V.
Okay, so it definitely seems like a medium hard problem, I say.
It's a medium hard? Medium hard?
I guess it depends. I think it's one of those problems that is probably one of the last problems that teams will be working on. We weren't sure if we were expecting at least one team to maybe solve the problem. At this point, before the freeze, 2 teams I think have solved the problem, if I recall correctly.
Yes, it seems so.
How many?
I think Utrecht and Scuola Normale Superiore. After the freeze, we don't know, but this is more or less consistent with what we expected in terms of teams trying to solve the problem.
Okay, so well, as we can see, it definitely feels like the European teams are very strong. So already during the freeze, 3 teams solved 7 problems. And the top 20 teams already sold 5. So, do you have any other comments about the scoreboard? Like, how would you expect like the scoreboard to be this way at this time, and what do you think will happen during the freeze?
Yeah, I think I would like to see someone solve problem I. I'm not sure if we'll see a solution or not. Problem D was a tricky problem that thankfully was already solved by at least one team. I think we might see another solution. I'm sure you've heard a lot about these problems with other people from the committee were here, but I guess our expectation is that D would kind of be a red herring where a lot of teams would potentially think it's a greedy algorithm and try to kind of solve it in a greedy way, and that's why we see a lot of wrong answers. For problem I think you just need a clever idea to kind of solve it. But I guess we'll see if someone solves it or not. But it would be nice to see every single problem being solved.
So yes, we can I can also try to show here the optimistic scoreboard here. I think.
So in the optimistic scoreboard, you're going to accept all of the pending solutions?
Yes, in the optimistic scoreboard, we accept all the pending solutions. Oh,
that's not optimistic.
Yes,
okay, that looks
here.
more optimistic.
Yeah, it seems very different than the scoreboard before the freeze. So I think maybe we'll see some surprises during this last hour.
Yeah, I hope so. Yeah, I don't know anything. Even though we have access to the submissions after the freeze, I haven't looked, so I honestly don't know anything. I'm just excited to also find out, like you.
So it's also important to mention that this is very important for some teams, since 4 teams may get their slots here to the World Finals,
and it seems like I guess at least first place hasn't qualified yet for the World Finals. Is that correct?
I'm not sure.
So I think is this the standings of teams that haven't qualified for the World Finals yet? So I guess the top 4 of this is the teams that would go if the standings stay.
Yes, if the standings stay as they are, but maybe I think they won't.
Yeah, we'll find out.
We'll find out. Unfortunately, we don't have any more desktop view, so we can see the desktop of students, obviously, because otherwise that would leak some information about the final standings, and I think I don't have anything more to say.
Thank you for having us. It was a lot of fun.
Thank you very much for everything.
Yeah, thank you. Thank you for bringing such a good problem.
Oh, thank you.
Done?
Hello again, and we are here with the sponsor for James Street. Can you talk a little bit more about yourself?
Sure. My name is Vasily. I am a software engineer at Jane Street. I have been there for almost 3 years. I am also an ICPC alumni. I have been participating in 6 consecutive seasons of ICPC myself. It's only obviously possible because of the 2020 World Finals, which didn't count. So I've been to 2 World Finals in Dhaka and in Bangladesh. In Dhaka and in Luxor. Now I work for Jane Street. So for those who don't know, Jane Street is a global trading firm. We are liquidity providers. It is a lot of scary words, but liquidity provision is a business of like going out to a financial market, finding people who want to do a trade, finding other people who want to be on the other side of the trade, and matching them with each other, so they would be able to execute this trade. It's not always trivial. For example, some people might not be able to match with each other because they are in different time zones, or they are in different parts of the world. They don't have a legal setup to trade with each other, but they have enough legal setup to trade with us, and we're happy to facilitate this trade and like provide this service and make like the prices better for everyone. We have lots of opportunities. We have full-time roles. They are open throughout the year. We have software engineering interns. We have other internships. For the internships, we offer 3 types of roles. We offer software devs, we offer traders, and we offer researchers. For traders, the trader roles is what in like a lot of other financial institutions, what's called quants. So if you want to like go out on exchange and see that there are like some people who are sending orders, some people who are taking those orders, and you want to like figure out who are the people who are sending orders, who are the people who are taking orders, what are they trying to do, for how much size, for what price they are willing to trade, why are they doing this, so who are the other people in the world who like might be on the other side of the trade and take this trade, and like we encourage you to apply to a trader position. Software engineer is like trader will tell you which exactly trade do we want to make, and you like have to facilitate it in the best way possible. So like if you want to make a system that like directly sends orders to exchange, this is like a software engineer role. We also have all other ranges of engineering roles at Jane Street. We have infrastructure for sending those orders. We have tools and compilers, like all sorts. And researchers is like if you want to go to this trader and like make the best tool for them to facilitate their research, this is the researcher role. It's a bit confusing, but it's more of an engineering role than anything else. Cool. We are very proud to be supporting this event. We are very happy to be a part of it. I have spent the last hours reading the problems, talking to other sponsors, some of the coaches, and like figuring out how to solve them. I was actually not paying too much attention to the stream, so that like I could keep it interesting for myself. It's a pity I'm not a participant anymore, because I would enjoy solving these problems. Like I think the problems are this looks like one of the best contests I ever saw at this level. Like the easy problems are tricky enough to make it interesting. I personally very much enjoyed problem A. I had to spend substantial amount of time thinking about it, much more than the first team that solved it. It probably should tell something. And the hard problems are also not very implementation heavy. I kind of enjoy this. Like if you just think about the problem, about problem E, which was just like written on this board, hard enough, long enough, you will just solve it. And same maybe for problem D. I actually love the golden ratio aspect of this problem. It's a very beautiful problem in my opinion.
So we can also see the scoreboard right now.
Yeah.
It is obviously frozen. And do you have any predictions of what will happen during the freeze?
Oh, that was interesting. So, based on what I solved the problems, I would probably guess that problem G should be solved more. So G. Like it is this problem like reads as a nasty one when you just try to read this, but I think it's actually should be pretty crackable if that's like the only thing you do. So like there is at least one team which only submits problem G. I would not be surprised if they solved it. Problem K is quite implementation heavy, unfortunately. So like someone will probably make it. There are lots of them.
You believe that maybe like ETH Zurich or University of Oxford will solve problem G?
Yeah, I would not be surprised at all. ETH Zurich is also solving I. I have no idea how to solve I actually. It seems a very hard one.
I mean, people did not try I at all during the 4 hours. So I'm not sure if people are going to solve I. If I had to make a guess, I say no.
Yeah, that one.
I think maybe I'm going to see more solutions for problem E. It's getting very tried.
I absolutely enjoyed problem E. It should be very much solvable in 5 hours. So I see there are teams. There is definitely at least one team which is Jagiellonian University in Krakow, which is like that's their only problem they're solving in the last hour. It is sort of hard to go wrong in this problem.
Problem E.
Problem E. I don't know. I feel like obviously it's not implementation. Very easy implementation wise, but I don't think they are submitting something wrong. Like I don't think it's like.
We can also see here the optimistic scoreboard, which means that all teams that submitted get accepted.
Yeah.
And we can see that things are quite different, but Utrecht and Delft University also take the lead, and maybe this is more important for the teams that did not qualify for the World Finals, since they are also competing for a spot. And we can see that Utrecht almost has basically the spot guaranteed. And well, we see that Oxford has tried a problem, since this is the optimistic standings.
Well,
and,
it's 4 seconds until the contest ends.
Yes, well, we don't know if it's accepted or not, so we will know in the closing ceremony, but I think much things will happen during the freeze. Well, it seems the contest is over, so no more submissions, and maybe we finish the interview here.
Yeah,
so,
sounds good.
Thank you very much for your time.
Thank you very much for having me.
Thank you, and bye. It's your first time in the live stream? Yeah. Okay, don't worry, it's like...
Do you have a quick time for a short post-contest interview?
Yeah, I guess we do.
Well, yeah, basically, well, let's go. So, you were first at the end of the freeze. How do you feel about your chances now?
Pretty good, honestly. I mean, looking at the scoreboard, we at least have chance to get into the World Finals now. Other than that, we're gonna
very
see.
interesting. We're not yet qualified for the World Finals, so we are first in the scoreboard before the freeze.
I mean,
so
that
we're
is-
really confused. We did not expect it at all.
So you really feel at the moment like this is a contest so far that went really well for you?
Yes. Definitely. I mean, practice went well over the past couple of months, but this was an outlier for sure.
So do you feel like it's been a relief sort of to feel like, oh, suddenly we are really breaking up in the higher ground?
Yeah, it does actually. Yeah.
Well, you all look very well, and you're looking very happy at the moment, so I like that.
Yes. It's
What did
also,
you find one of the more difficult problems?
I mean, there's a couple we didn't even attempt. From what I can tell, G and I we didn't even want to try. We spent a lot of time on D trying to figure out an easy solution, but we couldn't figure one out in the end. And for K, there's a lot of attempts, but we'll have to see in the final standing what happened there.
Good. Then we're going to go to the next team and ask them how everything went. Let's go ahead. Guys, do you have a quick moment for a post-contest interview?
Yeah, sure.
So, how are you feeling right now after the contest?
We'll see after the reveal.
What were your feelings before the freeze? Before you know what what the other contestants have done?
Well, we were hoping to solve at least one problem during the freeze.
Okay. But before the freeze, what was your standing? I don't know from the top of my head.
Sorry?
What was your standing before the freeze?
Pretty bad, like 30 or something.
Okay. And do you feel you have improved during the freeze?
Maybe.
Maybe. Okay. Yeah, that's okay. That's very fair to say. What do you find was one of your most difficult problems during the contest?
I think D, like it had very little results, but we did not solve it, but spent some time.
Okay. Very nice. We're gonna continue to another team, and then let's. Guys, do you have a quick moment for us for an interview just after the contest has ended? Yeah, you do?
Sure.
Sure, yeah. So how do you feel about everything right now after the freeze happened?
Well, that's great. We were debugging to the end, but unfortunate.
Unfortunate. You feel like you couldn't really get much done during the freeze, or?
Well, all the problems were hard, that's for one, and like our guy is still debugging, so we'll see if he finds it.
Yeah, you see your friend and he's still debugging on the problem.
Yeah.
Very nice. How do you feel about the problem set during this contest?
Yeah, I think it was good. There were a bit too many teams with the certain amount of problems, but overall pretty good.
How do you feel like what you saw in other contestants as well? How quickly they could solve other problems? How do you feel like you measure up to them?
We were a bit slow, definitely. So yeah, we were trying to solve more problems, but well.
Okay. Well, thank you very much. We're going to continue to another team. Thank you very much. Let's walk a little this way. Guys, hi. Do you have a quick time for an interview right now?
Sorry, what? I don't think.
You don't want to go for an interview?
I don't want to.
No? Okay, well then we continue to another team. Thank you. Guys, you have a quick time for us to talk about how everything went?
We can try.
Yeah, sounds perfect. So, well, before the freeze, I think you were doing pretty well, if I remember correctly. Do you feel like you improved a lot during the freeze?
But that's confidential information. Yeah, my lawyer tells me not to talk about it during the freezing period.
Okay. How do you feel? Did you qualify already for the World Finals before? Okay, so
Yeah,
you're
we're done.
already in the. You're already going to Azerbaijan. Are you looking forward to the competition there? Are you looking forward to the World Finals?
Yeah, of course.
About the problems for today, what problem did you like the most?
I guess the E is the most cool one in terms of the what you like the model you're working with. I like it, and I also like for me like the one I read and liked was the D problem. Yeah, not because we've solved it, we haven't like tried a lot, but the model is like cool. It's somehow like our perception of it is somehow like modified the Huffman coding. How it's called? Yeah, like the Huffman coding, like the optimal coding for the alphabet. Yeah, it's cool.
Okay.
But no idea how to solve it yet.
What do you think about the competition today? Like the other teams, do you feel like the competition was very strong today?
We talked yesterday about the teams here, and one of my teammates, won't say who exactly, said like really cool idea that it might be that like average like forces rating of participants here is like the only contest where it will be higher than at the World Finals, maybe. Like.
Okay.
Yeah. So yeah, like pretty strong competition, of course.
Very nice.
I believe like during the freezing time, like the last team had like 3 problems or so. I'm not exactly sure, but that's a lot for this contest. Yeah.
Okay. Well, thank you for your time. We're gonna go ask a few other teams. It's like. Guys, do you have a quick moment for a short interview right now?
Sure. Also, do you know where there are mouse pads?
I have no idea where we have mouse pads. Sorry, no. That's not my department during this.
Yeah.
But how have you guys been doing during this? During the contest?
I think it went not very well. Like below expectation, definitely. Yeah, slightly below. Like it wasn't a catastrophe, but it wasn't great. Yeah. I think previously we have like followed the scoreboard too little, but then we overcompensated and followed the scoreboard too much today. So like it's a balance between following the scoreboard and solving the easy problems, as well as like distributing the problems based on who is good at solving what kinds of problems.
Mm-hmm.
So we should probably have like tried more at solving the problems that we know that are yeah. We should have focused more on our strengths and less on the scoreboard.
Yeah.
But it's like very easy to say in hindsight, and yeah.
Yeah. Are there problems that you really liked about the problem set today?
I mean, F was a little cute, but this isn't like I think the problems are objectively good, but they're not the kind of problems I like, at least.
Yeah, I said exactly the same thing.
Yeah, it's like very code forces like, and we don't like that in Sweden.
Yeah, we really prefer data structures, and there's like no data structures at code forces or here.
Yeah, definitely.
Okay, so you feel like the problem set for today wasn't that much up your own alley, but it was better for other teams, maybe.
Yes, I mean, it's not a surprise. Like we expected the competition to be these sorts of problems, and it was these sorts of problems.
Are you in your last year of participating in ICPC, or
no?
Are you still going to continue after
We
this?
have one more year.
One more year. So you're going to train more on these style of problems for next year, potentially?
Yes, definitely. Or alternatively, try to qualify from NWork instead, because those problems are like way more up our alley.
We're good at NWork.
Yeah.
Okay. Well, I hope to see you as well at the NWork next year. Yeah. We're going to continue to another team, or shall we go back to Zat? Shall we go back, or...